You close your eyes, and in what feels like a single moment, your alarm is blaring. 8 hours have vanished, feeling more like a minute. It's one of the most common and yet baffling human experiences. We lose a third of our lives to this void, this little time jump we perform every night. But have you ever stopped to ask, where does that time actually go? It doesn't just feel misplaced, it feels like it was never there to begin with. Welcome to the science for deep sleep. If this kind of calm exploration into the universe helps you unwind, consider liking the video and subscribing to the channel. And wherever you are right now, whether near an ocean, a forest, a city, or somewhere quiet in between, feel free to share where you're watching or listening from. This nightly disappearing act is a profound clue about how we perceive time, and more importantly, about the consciousness that creates that perception. Your brain, it turns out, performs a nightly two-part magic trick that messes with your sense of reality. First, it systematically shuts down its own internal clock, plunging you into a timeless state where hours have no meaning. Then, in the wild theater of your dreams, it does the exact opposite. It grabs hold of time and stretches it, compresses it, and warps it into impossible shapes, creating epic sagas that unfold in just a few minutes of real-world time. The science behind this is stranger and more fascinating than you might think. We're going to explore the sleeping brain to see what happens to time when you're not looking. We'll look at the switches that turn off your internal stopwatch, and then dive into the bizarre physics of dream time, where the rules of reality get rewritten. What you're about to learn won't just change how you think about sleep, but maybe how you see every waking moment, too. The waking clock. How your brain tells time. Before we can understand how the brain loses time, we have to understand how it keeps time when we're awake. Our sense of time, called chronoception *, isn't like our other senses. There's no single, time organ. Instead, our perception of time is more like a symphony, performed by a whole network of different brain regions working together. It's less of a single clock and more like a team of specialist timekeepers. First, you have the conductor of this orchestra, the suprachiasmatic nucleus, or SCN. It's a tiny cluster of around 20,000 neurons in your hypothalamus, and it's your body's master clock. It doesn't track seconds or minutes, but the big, 24-hour cycle of day and night, your circadian rhythm. The SCN gets its main cue from light. Special cells in your eyes detect how bright it is and send a direct signal to the SCN, telling it if it's daytime or nighttime. The SCN then syncs up everything else: your body temperature, hormones, metabolism, and most importantly, your sleep-wake cycle. But the SCN is for the big picture. What about the feeling of seconds ticking by? For that, we turn to a different system, often called the pacemaker accumulator model. This involves a trio of brain regions: the prefrontal cortex, the basal ganglia, and the cerebellum. Think of it as your brain's internal stopwatch. One popular theory suggests it works like this: the basal ganglia generates a series of regular, rhythmic pulses. These pulses are sent to the prefrontal cortex, the brain's command center, which acts as the accumulator, basically counting the pulses. The more pulses it counts, the longer you feel an interval of time has been. Your attention is the key. When you're really into something, your prefrontal cortex is too busy to count every single pulse. As a result, time seems to fly by. But when you're bored, your attention is fixed on the passage of time. Your prefrontal cortex is counting every single pulse, and time seems to drag on forever. This is why watching a pot boil feels like an eternity, while a fun night with friends is over in a flash. The cerebellum also chips in, especially with timing related to movement and learned rhythms like catching a ball or playing an instrument. It's all part of a robust and flexible timekeeping network. So, when we're awake, we have a master clock, the SCN, for the 24-hour day, and a stopwatch system, the prefrontal cortex and basal ganglia, for the subjective flow of minutes and seconds, all tuned by our focus. This whole intricate network is what builds our experience of time. It's an active process. And that's exactly why it can be completely dismantled when we fall asleep. The Great Shutdown. How non-REM sleep erases time. The second your head hits the pillow, your brain starts shutting down the very machinery that creates your sense of time. This is why a full night of sleep can feel like an instantaneous jump from dusk till dawn. The feeling of lost time is a direct result of your brain actively wiping its own temporal slate clean. This all begins as you enter non-REM, or NREM, sleep. The thalamus, a gatekeeper for sensory information, effectively closes up shop. Sights, sounds, and other sensations from the outside world are blocked from reaching your cortex. Since our brain uses external cues to help anchor our sense of time, losing this data stream is a big deal. At the same time, that internal stopwatch powers down. Activity in the prefrontal cortex, the part of you that consciously pays attention and counts the ticks of time, drops dramatically. The accumulator is switched off. The pacemaker in the basal ganglia might still be firing, but if no one's there to count the pulses, time effectively stops accumulating. There's no active mind to witness it passing. This creates what scientists call a memory gap. Our perception of time passing is deeply tied to the memories we form. A busy day feels long in hindsight because we have a lot of memories to scroll through. But during deep NREM sleep, your brain isn't recording new experiences. It's busy with memory consolidation, sorting, and storing memories from the day. It's not recording the experience of sleeping. So when you wake up, your brain looks for the memory of the last 8 hours and finds nothing. An empty file. The only conclusion it can draw is that no time passed at all. It's a lot like general anesthesia. One moment you're counting backward, the next you're waking up in recovery, feeling like no time has passed. The best way to see this is to look at its opposite, insomnia. Someone lying awake for hours is painfully aware of every single minute. Their prefrontal cortex is on high alert, and time crawls. Yet, research shows many people with insomnia get fragmented bits of sleep they're completely unaware of. They'll swear they were awake all night, but hours have vanished from the clock. But this doesn't mean your brain is completely oblivious. Many people have had that uncanny experience of waking up just moments before their alarm. This isn't just a coincidence. Studies show that when people have a set time they need to wake up, their bodies begin to release hormones like cortisol in the time leading up to that moment, as if preparing for the event. This suggests there's a deeper, subconscious timekeeping mechanism that we can apparently set, even in our sleep. So, during NREM sleep, your brain is actively curating your experience of time. It shuts out the world, powers down the conscious stopwatch, and stops recording new memories, creating the powerful illusion of a time jump. But this quiet, timeless void is only the first act. The time warp. How REM sleep distorts time. After cycling through the timeless void of NREM sleep, your brain enters rapid eye movement, or REM, sleep. Here, the rules of time aren't just bent, they're shattered. This is where most vivid dreaming happens, and inside these dreams, time becomes an elastic, malleable substance. You can experience epic adventures spanning what feels like days or weeks, all packed into a REM cycle that might only last 20 or 30 minutes. This is the total opposite of NREM sleep. Here, time doesn't disappear, it expands. So, what's going on? How does the brain create these sprawling, time-dilated stories? One compelling theory involves something called hippocampal replay. During REM sleep, the hippocampus seems to reactivate and replay neural patterns from the day. Think of it like your brain reviewing the footage of your waking life, but on fast forward. Animal studies have shown these replay events can be compressed, running many times faster than the original experience. It's possible our dreams are the subjective experience of this accelerated replay. Your brain might be stitching together fragments of memories and playing them back in a jumbled, sped-up sequence, which your dreaming mind interprets as a long, continuous story. Another key factor is the complete lack of physical feedback. During REM sleep, your brain paralyzes your muscles to prevent you from acting out your dreams. This has a bizarre effect on how you perceive movement in a dream. This has been tested with lucid dreamers, people who know they're dreaming. In these studies, lucid dreamers are asked to do a task, like counting or squats, and signal the start and end with eye movements. The results are fascinating. For a purely mental task like counting, the time it takes in a dream is almost identical to when you're awake. But for motor tasks, it's a different story. Performing squats in a dream takes significantly longer in some studies, as much as 40% longer than in real life. Researchers think this is because the brain sends the command to move, but it never gets the feedback from the muscles confirming the action is complete. This delay might make physical actions in the dream world feel like they're in slow motion. This is the opposite of what you see in a movie like Inception, whose time dilation concepts are pure science fiction. The real science suggests physical actions can slow down, not speed up. The feeling of a dream lasting for days is likely due to that high-speed memory replay we talked about, not this motor slowing effect. So, a dream can feel both slow in its moment-to-moment action and incredibly long in its overall story. It's a paradox that shows just how weird dream time is. On top of all this, the neurochemistry of REM sleep is completely different. The brain is flooded with the neurotransmitter acetylcholine, leading to high brain activity similar to being awake. At the same time, chemicals like serotonin and norepinephrine, crucial for waking attention and logic, are dramatically suppressed. This unique chemical cocktail likely contributes to the bizarre, illogical, and time-distorted nature of our dreams. If you're geeking out about the mysteries of the brain as much as I am, take a second to subscribe and hit that bell icon. We explore incredible science like this every day, and you won't want to miss what's next. When the clock breaks, sleep deprivation and chronotypes. Understanding how sleep manipulates time also shows what happens when the system breaks. If you don't get enough sleep, it's not just that you're tired. Your entire sense of time becomes warped. Studies have shown that after just one night of missed sleep, the brain's biological stopwatch seems to speed up. This leads to a strange split in how you perceive time. In tasks where you estimate time moving forward, you tend to underestimate it. A minute feels shorter. However, looking back, that sleepless period feels like it lasted an eternity. Brain imaging shows that a sleep-deprived brain has to work much harder to perform time perception tasks. It's struggling to keep its clocks in order, which leads to the slowed reaction times that make sleep deprivation so dangerous. On top of that, our individual body clocks, our chronotypes, also play a big role. You probably know if you're a morning lark or a night owl. This is a deep biological trait. Some fascinating research suggests that evening types, or night owls, may be more prone to feeling like time is dragging. This could be related to a misalignment between their internal biological time and external social time, like having to wake up early for a job. The link between chronotype and cognitive performance, like memory, is complex and an active area of research, but it shows that a stable, well-aligned circadian rhythm is key to a stable perception of time. When that rhythm gets disrupted, the whole symphony of timekeeping in your brain can fall out of tune. So, what is time, anyway? So, where does this leave us? We've seen the brain's waking clocks, the timeless void of NREM sleep, and the bizarre time bending of our dreams. It all points to a startling truth: our sense of time is not a passive window to reality. It's an active, and fragile, construction of the mind. Sleep is the ultimate proof. Every night, your brain demonstrates this by deconstructing the very idea of time. By shutting down attention, memory formation, and sensory input, it shows us that without a conscious observer to count the seconds, time for all intents and purposes, ceases to exist. The 8 hours you lose aren't lost, they were simply never created, because the architect of time, your conscious brain, was off duty. Then, in REM sleep, the brain shows its power by doing the opposite. It takes bits of memory and emotion and builds new timelines from scratch. It proves that time isn't just something to be measured, but something to be manipulated. It can be stretched, compressed, and reordered, creating subjective experiences completely untethered from a clock on the wall. The dream that felt like a week was, subjectively, just as real as the 8 hours that felt like a minute. Both are illusions crafted by the brain. This reveals the difference between physical time, the progression of events in the universe, and subjective time, our personal experience of it. Your brain is a time machine, but it can't move your body through the physical world. Instead, it stretches and compresses your experience of time. When you're engaged and forming rich memories, life feels full. When you're disengaged or in deep sleep, it compresses or erases time, creating gaps in your perceived existence. So, the question, what happens to time when you sleep, has a two-part answer. During non-REM sleep, time passes in the world, but your brain switches off its ability to perceive it. During REM sleep, your brain becomes a storyteller, inventing its own temporal narratives. This suggests our experience of time isn't something that just happens to us, but something we help create. By choosing where we direct our attention and by seeking out new experiences, we can actively shape our own temporal reality. Sleep is just the most powerful reminder that the clock on the wall and the clock in our mind are two very different things. And arguably, the clock in our mind is the only one that truly matters. The next time you wake up, startled by your alarm and wondering where the night went, remember the profound magic that just happened. Your brain proved that the seamless flow of time you experience every day isn't a given. It's a carefully constructed story, maintained by a symphony of neural activity.
During your deep, dreamless sleep, the conductor left the stage, and the illusion of time vanished. That's your time jump from night to morning. Then, in the chaos of your dreams, a new conductor took over, one who prefers jazz over classical, improvising wild, distorted timelines where moments stretch into eternities. You experience both the absence of time and the warping of time every single night. It's the most powerful reminder that our perception is not a perfect window onto reality, but a story our brain tells itself. The 8 hours didn't go anywhere, you simply stopped creating them. And that leaves us with a final question for your day. If your brain can so easily discard and manipulate time while you're asleep, what does that say about the time you're experiencing right now? Share your own strange experiences with dream time in the comments below. Have you ever had a dream that felt like it lasted for years? And don't forget to subscribe for more journeys into the science of you. Part 2: What time really means in physics. When people say that 8 hours of sleep vanished in an instant, it sounds as though time itself has done something strange, as if the night somehow folded up and disappeared. But before we can really ask what happens to time when you sleep, we have to step back and ask a much quieter question. What is time, in the first place? Not the feeling of time, not the stress of being late, or the softness of a lazy afternoon, or the way a beautiful evening seems to slip past too quickly. I mean time in the language of physics. The thing clocks are supposed to measure. The thing that lets a planet circle a star, a flower open in the morning, and your own body move from one breath to the next. It is one of the strangest facts of life that we use time every day, and yet most of us rarely stop to ask what we mean by it. We check it on our phones. We schedule our lives around it. We complain that we never have enough of it. But if someone asked us to hold it in our hands, or point to where it lives, or explain exactly what it is made of, we would suddenly go very quiet. And that silence is understandable, because time is not like a chair, or a glass of water, or a tree in the wind. You cannot touch it directly. You cannot pour it, weigh it, or place it on a table. In physics, time is not really treated like a thing you can pick up. It is more like a framework, a way of describing change, a way of placing events in order, a way of saying not just what happened, but when it happened, and in what sequence. That may sound almost too simple, but the simple ideas are often the deepest ones. Imagine, for a moment, a world with no change at all. No sunrise. No shadows moving across the floor. No heartbeat. No cooling tea. No leaves falling. No thoughts arriving, fading, and being replaced by others. In such a world, what would time even mean? If absolutely nothing changed, there would be nothing to compare one moment to another. No before, no after, no waiting, no aging, no motion. In that sense, time and change are deeply intertwined. We notice time because things do not stay still. This is why the first clocks were never really measuring time directly. They were measuring reliable change. A sundial watches a shadow move. An hourglass watches sand fall. A candle clock watches wax burn down. A pendulum swings back and forth. A quartz crystal vibrates. Inside an atomic clock, atoms shift in exquisitely regular rhythms. All a clock really does is take some repeating process in nature and use it as a reference. It says, in effect, this thing changes in a stable way, so we can count those changes and call the count time. That is a surprisingly humbling thought. The clocks on our walls and wrists feel so authoritative, so certain, but they are not little boxes full of time. They are just counters of motion. They are devices built to follow regular patterns. The clock is not time itself any more than a ruler is space itself. A ruler helps measure distance, but it is not distance. A clock helps measure duration, but it is not duration. Human beings have always understood this, even before they could explain it scientifically. Long before atomic clocks and modern physics, people watched the sky. They watched the sun return, the moon change shape, the season cycle. The earliest timekeeping was really sky watching. Day followed night. Winter gave way to spring. The stars rose and disappeared in dependable patterns. These cycles gave people something stable to hold onto in a world full of uncertainty. Time, at least at first, was the recognition that nature had rhythms. And rhythm is such a beautiful word to use here, because physics often meets ordinary life in the language of rhythm. A heartbeat is a rhythm. Breathing is a rhythm. Waves reaching the shore are a rhythm. Sleep itself is a rhythm. Even before we get to the deeper mysteries, time has always been tied to repetition, to motion, to recurrence. But physics eventually wanted something more precise than sunrise and moonlight. It wanted a way to describe motion, causality, and change with exactness. If a ball rolls down a hill, how long does it take? If light travels from a star, when did it leave? If a radioactive particle decays, how likely is it to survive another second, another minute, another year? To answer those questions, time became one of the basic quantities in the language of science. In everyday life, it is easy to think of time as a river carrying us forward. That picture feels natural. It is how our lives seem to unfold. Childhood becomes adulthood. Morning becomes evening. Yesterday falls behind us and tomorrow waits ahead. For a long time, physics shared something close to that intuition. In the classical view, especially in the age of Isaac Newton, time was treated almost like a universal stage clock. It ticked the same way for everyone, everywhere. The universe changed within time, but time itself remained steady in the background, calm and absolute. That older picture is still useful for most ordinary life. If you are cooking pasta, catching a train, or timing a walk around the block, you do not need the universe to become exotic. You can think of time as a shared, reliable flow, and the world will behave exactly the way you expect. In that sense, Newton's style of time still fits the scale of human life remarkably well. It tells us what our instincts already suspect. Things happen in sequence, clocks help keep track, and causes come before effects. But even here, there is already an important distinction to make. Physics cares about measured time. Human experience cares about felt time. And those are not always the same thing. A minute on a clock is a minute whether you are laughing with friends or staring at the ceiling in the middle of a sleepless night. The physical interval does not stretch just because you are bored, and it does not shrink just because you are happy. A cesium atom does not become nostalgic. A pendulum does not get anxious. A quartz crystal does not feel impatient in a waiting room. Physics, at least at this level, is dealing with time that can be measured from the outside, not the rich, slippery inner experience of time from the inside. That difference matters a lot for our question about sleep, because one of the great themes running beneath this whole topic is that there may be a gap between time as the universe measures it and time as the mind experiences it, and sleep lives right in that gap. But let us stay with physics for a little longer, because if we move too fast, we miss something important. Time in physics is not just about clocks. It is also about order. It tells us how to place events in sequence. This came first. That came later. The glass fell, then it shattered. The seed was planted, then the tree grew. A star formed, burned for millions or billions of years, and eventually dimmed. Without time, those sentences would lose their shape. Physics uses time to connect one state of the world to another. At one moment, the kettle is cold. Later, it is hot. At one moment, Earth is here in its orbit. Later, it has moved a little farther along. At one moment, your heart is filled with air and blood moving in quiet cycles. Later, it has already completed another beat. Time lets us describe not just the world, but the world in motion. This is why so many basic physical ideas contain time hidden inside them. Speed is distance divided by time. Frequency is how often something repeats in a stretch of time. Acceleration is how quickly speed changes over time. Decay rates, growth rates, rotation, vibration, pulse, orbit, all of these are really stories about how things change with time. If you remove time from physics, motion itself becomes difficult to talk about. A moving planet becomes just a planet. A melody becomes just a pile of notes. A life becomes just a still image. Time gives movement its narrative. It gives change its grammar. There is something almost poetic in that. Time is what turns a universe of objects into a universe of events. And events are what make reality feel alive. Think about the difference between a photograph and a film. A photograph captures a single arrangement. A film gives you sequence. Someone raises a hand. Rain begins. A door opens. A face changes from worry to relief. Physics needs time because the universe is not a single photograph. It is not one frozen frame. It is an unfolding pattern of relations. Time helps describe that unfolding. Of course, even this is not the whole story. Because the deeper physics goes, the stranger time becomes. For a while, it seemed enough to imagine time as a universal clock in the background. But eventually, science discovered that time is not quite as simple as that. Later, we will get to Einstein, to relativity, and to the unsettling possibility that different observers do not always agree about time in the way common sense expects. But before we go there, it helps to get this calmer, more basic foundation in place. Because relativity is not really a replacement for the ordinary idea of time. It is a refinement of it. It shows that time is real, measurable, and woven into the structure of the universe, but also more flexible than our ancestors ever suspected. For now, though, let us keep things gentle. At the beginner level, the physics view of time can be understood through three quiet ideas. First, time is what lets us describe change. Second, time is what lets us place events in order. Third, clocks do not create time. They only track regular processes that stand in for it. Once you sit with those three ideas, something subtle begins to happen. The mystery of sleep starts to shift. Because if time in physics is tied to change and order, then sleep does not look like the universe stopping. The earth keeps turning while you sleep. Your heart keeps beating. Your lungs keep moving air. Hormones rise and fall. Brain activity shifts through stages. Cells repair damage. Memories are sorted. Outside your window, the night continues whether you notice it or not. None of that pauses just because you are unconscious. So from the perspective of physics, the answer is already beginning to take shape. Time does not vanish when you sleep. Physical processes continue. Clocks continue. Rhythms continue. The world does not wait for your awareness to return. And yet, to you, it may still feel as if the night was simply gone. That is where the real tension lives. There is measured time, and there is lived time. There is the time the universe keeps, and the time the mind reports back to you. When those two line up, life feels straightforward. When they drift apart, things become uncanny. A dream lasts what feels like hours, yet only minutes have passed. A sleepless night feels endless, yet the clock says dawn came just as quickly as always. A deep, dreamless sleep seems to erase itself entirely. The more quietly you look at it, the more the question changes. It is not really, does physics lose time when you sleep? It is closer to this: what part of the human experience depends on time itself, and what part depends on the mind's ability to notice, record, and interpret time. That difference may sound small, but it changes everything. There is another gentle way to think about it. Imagine two people on the same train journey. One stays awake the entire ride, watching every station pass by. The other falls deeply asleep just after departure and wakes moments before arrival. The train traveled the same distance. The tracks existed. The landscape passed. The schedule held. Physical time did exactly what it always does. But the inner experience of the journey was completely different. For one person, it was long and continuous. For the other, it was almost nothing at all. That does not mean the train disappeared. It means experience has its own logic. And physics, by itself, is not quite enough to explain that logic. Physics tells us what clocks do. It tells us how systems evolve. It tells us how to measure intervals and order events. But to explain why a person can lose all sense of those intervals during sleep, we need another layer. We need the brain. We need perception. We need consciousness. Still, physics gives us the clean floor to stand on before we enter that room. It tells us that time is not simply a feeling. It is not invented by the mind from nothing. The mind can distort time, ignore time, compress time, or fail to record time, but the mind does this against the backdrop of an external order that keeps unfolding. If you go to sleep at midnight and wake at 8 in the morning, the clock did not hallucinate those hours. The world actually moved through them. This also helps explain why physical science had to become so obsessed with better and better clocks. The more precisely we can measure regular change, the more precisely we can describe the universe. That is why humanity moved from shadows and candles to pendulums, then to quartz oscillations, and finally to atomic clocks. In the modern scientific world, 1 second is defined using the incredibly stable vibrations associated with cesium atoms. It is a stunning achievement. We have found patterns in nature so regular that they let us split time into pieces with extraordinary precision. And yet, for all that precision, none of those clocks can tell you why 10 minutes of waiting for bad news feels longer than an hour spent half asleep on a sofa. They can tell you how much measured time passed, but not how that duration felt from the inside. That is not a failure of physics. It is simply a sign that the world has layers. One layer is the physical order of events. Another is the biological machinery that tracks rhythms inside the body. Another is the conscious experience built on top of both. You can almost think of it as 3 nested worlds. The universe has its temporal structure. Your body has its internal timing systems. And your mind has its own story about how time feels. Most of the time those 3 worlds overlap neatly enough that we do not notice the difference. Sleep is one of the great exceptions. It exposes the seams. And perhaps that is why sleep feels so mysterious. It is not just rest. It is a nightly demonstration that time, as humans live it, is more than a number on a clock. It depends on awareness. It depends on attention. It depends on memory. When those things soften or disappear, time can seem to soften or disappear with them, even though the physical world continues humming along with complete indifference. If this kind of calm wandering through science is helping you settle in, you can gently leave a like, subscribe to the channel, or tell me in the comments where in the world you're listening from tonight. It is always nice to imagine these quiet questions drifting through different rooms, different cities, and different corners of the night. Now, before we close this part, it helps to gather the thread. In physics, time is not usually treated as a substance. It is not a fluid flowing through the universe like some invisible river you could bottle up. It is better understood as part of the structure that lets change be described and events be ordered. Clocks do not contain time. They track stable rhythms. Motion, growth, decay, orbit, and causality all depend on time because they all depend on sequence. And most importantly for our larger question, physics does not suggest that time itself switches off when you sleep. The stars do not pause. The Earth does not stop rotating. Your cells do not enter some magical exemption from the universe. Physical processes continue. What changes is your relationship to them. That may be the quiet revelation hiding underneath the whole topic. When you sleep, the universe does not lose time. You lose contact with the ordinary experience of it. And that means the next step in our journey is no longer really about clocks. It is about the observer behind the eyes. The one who can watch a minute drag endlessly, or vanish in a blink. The one who can lie awake and count the night, or sink so deeply into sleep that 8 hours leave almost no trace at all. Physics gives us the stage. Now we have to understand the audience. Because once we know what time means in the world, the next question becomes much more personal. Why does the brain experience that world so differently from one moment to the next? And why, when consciousness fades, does time so often seem to fade with it too? That is where we go next. Part 3. The difference between real time and felt time. There is a strange split at the heart of human life, and most of the time we barely notice it. On one side, there is the time the universe keeps. The quiet, indifferent, measurable time of clocks, orbits, vibrations, and change. The kind of time that lets a sunrise happen at a particular hour, a heartbeat in a certain rhythm, and the earth complete another turn in the dark. On the other side, there is the time you feel. And those two are not always the same. You already know this, even if you have never put it into words. A pleasant evening can disappear almost before it begins. A painful conversation can seem to last forever. A long drive can feel short if you are lost in thought, yet 10 minutes in a waiting room can feel almost unbearable. The clock on the wall keeps moving at its steady pace, but your inner world does something entirely different. This is one of the most intimate mysteries of time. Not what it is out there, in the language of physics, but what it becomes once it enters a human mind. Because the truth is, we do not simply live in measured time. We live in interpreted time. We live in a personal, flexible, deeply subjective version of reality where an hour can feel like a blink, or a blink can seem to stretch into something much longer. And if we want to understand why sleep makes time feel as though it disappears, we first have to understand this quieter fact. The brain does not experience time like a clock does. It creates a feeling of time, and that feeling can bend. That may sound almost obvious at first, but the more you sit with it, the stranger it becomes. Think about what it means. It means that what you call the present moment is not simply handed to you raw and untouched. It is shaped, edited, constructed. It arrives as an experience, not as a perfect measurement. The world happens, but your mind interprets what happened, and part of that interpretation is duration. This is why two people can go through the same event and come away with very different feelings about how long it lasted. A child in a classroom might feel an afternoon dragging on endlessly, while the teacher, busy and distracted, feels the day vanish almost too quickly. A person stuck in traffic while anxious and late may feel every red light as a kind of punishment. Another person, listening to music and drifting into thought, barely notices the same delay. Nothing has changed in external time. The minutes remain the same. The clocks agree. The sun's position agrees. The world, in that sense, is stable. But experience is not. That difference between real time and felt time is one of the most important ideas in this entire topic, because sleep sits right at the center of it. Sleep does not stop the world, but it transforms experience so completely that the time passing outside you no longer feels like the time passing within you. And to understand why, we need to look at what the brain is actually doing when it senses duration. For a long time, it was tempting to imagine that somewhere inside the human head there must be a single internal clock, some neat little device counting away the seconds like a watch in a drawer. That image is simple, elegant, and very satisfying. But the brain does not seem to work that way. There is no one tiny clock inside you that rules all your sense of time. Instead, what science suggests is more subtle. The feeling of time appears to emerge from networks of attention, memory, expectation, bodily rhythm, and changing brain states. In other words, your experience of time is woven together from many processes at once. This is one reason time perception is so fragile. Change your attention, and time changes. Change your emotional state, and time changes. Change the density of memory, and time changes. Change whether you are awake, distracted, dreaming, terrified, bored, absorbed, or half asleep, and time changes again. The clock remains innocent in all of this. It simply counts. It does not know or care whether you are waiting for a text message, recovering from heartbreak, falling in love, or slipping into deep sleep. It marks intervals. That is all. But the human mind turns intervals into lived experience, and that is where things become beautifully unstable. Perhaps the easiest place to begin is attention. Attention is one of the great sculptors of felt time. When your attention is directed toward time itself, time tends to feel larger. When your attention is elsewhere, especially when it is deeply captured, time often seems to shrink. This is so common that people almost joke about it. Time flies when you are having fun. A watched pot never boils. These are not just old sayings. They are observations about the machinery of awareness. Imagine sitting alone, waiting for an important phone call. You check the time. 2 minutes have passed. You wait longer. Surely it must be 10 minutes by now. You check again. Only 3. The mind, in moments like this, becomes obsessed with duration. It circles it, counts it, feels every tiny segment of it. The more closely you monitor time, the more substantial it seems. Now compare that with the opposite kind of experience. You begin reading something interesting late in the evening, or working on a project that absorbs you, or speaking to someone in a conversation that draws you completely in. Your attention stops resting on duration. It rests on content, meaning, emotion, curiosity. By the time you look up, a large portion of the night may already be gone. That does not mean time sped up in the physical world. It means you stopped continuously sampling it. This is one of the most useful ways to think about felt time. It is not simply passively received. It is sampled by consciousness, almost the way light is sampled by the eye or sound by the ear. When attention repeatedly checks the passage of time, experience fills with markers. When attention stops checking, fewer markers stand out. The interval may later feel shorter, smoother, less textured. And attention is only one part of the story. Memory may be even more important. There is a quiet relationship between memory and duration that shapes much of human life. In a way, we often judge how long something felt by how much mental material we can retrieve from it. A period rich in impressions, novelty, detail, and emotional content often seems fuller. A period with very few memorable features often compresses. This is why childhood summers can feel vast in memory. A great many things were new then. the mind was still collecting firsts. First places, first questions, first fears, first fascinations. So many experiences stood out sharply enough to be recorded. Looking back, those years feel spacious. Adulthood often behaves differently. Routine settles in. Days begin to resemble one another. The same roads, the same rooms, the same responsibilities. When fewer moments stand out distinctly, time can begin to blur. A month passes, then several, and it can feel as though life is moving more quickly than it once did. Again, the clock is not responsible. The difference lies in how much of life becomes memorable enough to create a sense of density. This becomes especially important when we think about sleep. During waking life, memory helps stitch time together. When memory formation weakens or vanishes, as it often does in deep sleep, the experience of duration can collapse. The night may have physically unfolded in full, but if the mind kept almost no record of it, then from the inside it may feel as though almost nothing happened at all. So already we can see the outline of the answer beginning to form. Real time is the measured progression of events. Felt time is the brain's interpretation of that progression through attention, memory, emotion, and awareness. They overlap, but they are not identical. And once you understand that, many odd experiences begin to make more sense. Take boredom, for example. Boredom is a remarkable state because it does not just feel empty. It feels long. Time seems to thicken inside it. A boring lecture, a silent elevator ride, a slow queue in a bright supermarket, all of these can acquire a weight that has very little to do with the number of actual minutes involved. Why? Because boredom often turns attention back onto duration itself. There is not enough stimulation to occupy the mind, but there is enough awareness to notice the passing of time. You become unusually aware of waiting. You experience not just the event, but the interval around it. The opposite experience is often called flow. A flow state is a period of complete absorption, where action and attention become almost seamless. It can happen in music, in writing, in sports, in conversation, in building, drawing, solving, creating, even in certain kinds of peaceful routine. In such states, self-consciousness softens. Monitoring softens. The constant internal commentary about how long things are taking becomes very faint. Afterwards, time may seem to have disappeared. Both boredom and flow reveal something important. Felt time is not fixed because consciousness is not fixed. The brain does not stand in one stable relation to the world. It changes mode. It narrows. It expands. It monitors. It forgets to monitor. It becomes anxious, absorbed, exhausted, afraid, delighted, restless, dreamy. And each of these states leaves a different signature on duration. Emotion plays a powerful role here too. Fear is one of the most dramatic examples. People in frightening or dangerous situations often report that time seemed to slow down. A car swerves. A glass slips from a hand. An accident almost happens. Suddenly the world feels stretched, hyper-detailed, strangely spacious. It is as though the moment refuses to end. For years, people wondered whether the brain literally speeds up in those moments, somehow processing more reality per second. The answer appears to be more subtle. What likely changes is not the physics of time, nor even necessarily the raw rate of perception in the moment, but the density with which the experience is encoded. Highly emotional events often leave richer memory traces. Later, when looking back, the event feels longer because it contains so much detail. In a calmer sense, awe can do something similar. A great landscape, a clear night sky full of stars, an enormous cathedral, the first sight of the ocean after a long journey, these can all make time feel strangely spacious. Not because you have stepped outside physics, but because attention has widened and deepened. The moment feels more inhabited. This is one of the quiet beauties of time perception. The way time feels is not merely a technical problem. It is also an emotional one. Different inner states generate different temporal worlds. And that brings us closer to the sleeping mind, because sleep is not simply the absence of waking. It is a different brain state entirely, and different brain states mean different experiences of time. But before we go fully into sleep, it helps to linger a little longer on one particularly fascinating idea. The present moment, the now you feel yourself living in, may not be as simple as it seems. In ordinary life, it feels obvious that you are located in the present, here, now, this instant. But neuroscience suggests that your experience of now is not an instant in the purest sense. It may be more like a brief constructed window, built from signals arriving at slightly different times and woven together by the brain into a coherent scene. Think of what has to happen for you to experience even a simple moment. Light reaches your eyes. Sound reaches your ears. Pressure reaches your skin. Signals travel through nerves. Different brain regions process them at different speeds. The brain then has to bind all of that into something stable enough to experience as a single present world. That takes time, which means that what feels immediate may already be, in a small but real sense, slightly delayed. The conscious present is not always the raw edge of reality. It is more like a gently edited broadcast. Close to real time, yes, but not quite identical to it. This matters because it reminds us once more that felt time is an achievement of the nervous system. It is built. As long as the building process works smoothly, we do not notice it. But as soon as the system is altered, by exhaustion, dreaming, stress, drugs, meditation, illness, boredom, trauma, or sleep, time begins to show its seams. You can see these seams in very ordinary life. Notice how quickly time can change character across a single day. Morning may feel crisp and segmented. Afternoon may blur. Evening may either drift slowly or vanish completely depending on your state of mind. The hour before a difficult conversation may feel longer than the conversation itself. A sleepless night can feel endless, while a deep sleep can erase whole stretches of darkness as if they were never lived. It is almost as though human consciousness is not standing beside time, calmly watching it pass, but actively negotiating with it. And perhaps that is not so far from the truth. The mind seems to be continually estimating duration from the material available to it. Attention gives one kind of material. Memory gives another. Body rhythms contribute their own signals. Expectations matter too. If you expect a wait to be short and it becomes long, time often feels more burdensome. If you expect a process to take a while, the same interval may feel gentler. Prediction shapes duration more than we sometimes realize. That may explain why the first night in a strange place often feels different from the fifth. Novelty and uncertainty alter the mind's relation to time. You notice more. You monitor more. You compare more. Familiarity smooths the edges and reduces friction. And again, this is important for sleep. Because sleep is not just the body resting. It is the mind entering states where attention loosens, sensory input changes, memory formation changes, and conscious monitoring fades. Once those ingredients shift, your experience of time cannot help but shift too. Let us take a quiet example. Imagine someone lying awake in bed, unable to sleep. They turn over, adjust the pillow, check the clock, listen to a distant sound, think about tomorrow. Check the clock again. Notice the warmth of the room, the pressure of the sheets, their own annoyance rising. In such a state, time often feels oppressive. Every minute announces itself. Now imagine that same person finally drifting off into deep sleep. The body remains in time. The room remains in time. Night continues. But attention disappears. Deliberate monitoring disappears. The person is no longer standing guard over duration. And when they wake again, there may be almost no felt bridge between the 2 points. One moment they were worrying in the dark. The next, the morning is already there. The contrast is astonishing, and it reveals something essential. Felt time requires a kind of ongoing participation from consciousness. When that participation intensifies, time grows heavier. When it vanishes, time may seem to vanish too. This is also why dream time is so fascinating. Dreams do not always erase time. Sometimes they remake it. A dream can feel elaborate, layered, extended, emotionally full. Entire conversations happen. Journeys happen. Places appear. Yet in measured time, the dream may have occupied only a small portion of the night. Here again, felt time and real time drift apart, not because one is false and the other is true, but because they belong to different levels of experience. One belongs to the world as measured. The other belongs to the mind as lived. And human life always sits between them. If you are listening to this in bed, in that soft place between curiosity and sleep, it may be worth pausing here for a second and noticing your own relationship to time tonight. Maybe the room feels quiet and stretched. Maybe the day already feels far away. Maybe you can sense how different time becomes when you stop chasing it and simply observe it. If this slow kind of exploration is something you enjoy, you can gently subscribe, leave a like, or share a thought in the comments later on. There is something comforting about knowing other people are lying in different corners of the night, wondering about the same strange things. Now, there is one more layer to add before we close this part, and it may be the most important. The difference between real time and felt time is not just a scientific curiosity. It affects how we live. It changes how we remember our lives. It changes how we suffer. It changes how we wait, love, fear, hope, and rest. Some people feel as though years are slipping by too quickly. Others feel trapped in long seasons of pain. Much of that experience is shaped not only by what happens, but by how the mind organizes time around what happens. When life becomes repetitive, time can compress. When life becomes overwhelming, time can drag. When life becomes meaningful and attended to, time can feel rich. When consciousness is withdrawn, as in deep sleep or anesthesia, whole intervals can disappear from experience. This means that the human relationship with time is never purely physical. It is also psychological, biological, and deeply personal. That does not make felt time unreal. It only makes it different. Pain that feels long is real pain. Joy that feels brief is real joy. The mind's way of shaping time matters because the mind is where life is lived. We do not live inside the equations of physics alone. We live inside bodies, memories, moods, and changing states of awareness. Physics sets the stage, but experience is the play. And nowhere is that clearer than in sleep. Sleep is the place where the split between measured time and experienced time becomes impossible to ignore. The body remains obedient to clocks, rhythms, and cycles. But the mind no longer reports the passage of time in the same way. Sometimes it erases. Sometimes it distorts. Sometimes it produces dreams that feel larger than the minutes that contain them. Sometimes it gives us nothing at all except a gap between darkness and morning. So if part 2 gave us the steady, external idea of time, part 3 gives us something softer and more human. It tells us that the time the universe keeps and the time we feel are partners, but not twins. Real time is what clocks measure as events unfold. Felt time is what consciousness makes of those events through attention, emotion, memory, expectation, and awareness. And once we know that, the next step becomes obvious. We have to ask what happens to felt time when consciousness itself begins to fade. Because that is the doorway into sleep. That is the moment when the mind stops standing in the stream the way it usually does. And that is where the mystery deepens. The world keeps moving, but your ability to feel that movement starts to change. And very soon, we arrive at one of the most intimate transformations in all of human experience: the falling away of awareness itself. Part 4: What happens to awareness as you fall asleep? There is a moment each night that almost nobody remembers clearly. It is not the moment you get into bed, not the moment you turn off the light, not even the last thought you can recall before morning. It is the quieter moment after all that, the one where awareness begins to loosen its grip. For a little while, you are still here. You can still hear the room. You still know who you are, where you are, what tomorrow is. Then something begins to soften. Thoughts lose their sharp edges. The world grows less demanding. The steady thread of being awake starts to fray. And before long, the person who is lying there, listening, thinking, waiting, slips gently out of ordinary consciousness. It happens so often that it feels ordinary. And yet it is one of the strangest transitions in human life. Every single night, you cross a boundary between two radically different ways of existing. On one side is waking awareness, clear enough to track time, remember plans, notice sounds, and maintain a stable sense of self. On the other side is sleep, where that stable awareness fades, breaks apart, or disappears completely. Between them lies a threshold so subtle that we usually miss it. That threshold is what we are exploring now. Because if we want to understand why time seems to vanish in sleep, we first have to understand what happens to the observer. The part of you that usually notices time, measures it, and turns it into lived experience. When that observer begins to dim, time does not exactly stop, but your contact with it changes in a deep and intimate way. And it all begins with falling asleep. At first glance, that sounds simple enough. You get tired, you close your eyes, and you drift off. But under the surface, the transition is far more intricate than it appears. Falling asleep is not like a light switch flipping from on to off. It is more like a slow rearrangement of the entire mind. The brain does not abandon wakefulness all at once. It lets go in stages. If you have ever tried to stay awake when you were deeply tired, you may have already felt this in your own body. You are still awake, technically, but not fully. A thought begins, then dissolves halfway through. A sentence in your head stops making sense. An image appears that feels almost dreamlike, even though you know you are not asleep yet. The room is still there, but it seems further away. Time still exists, but it starts to lose its sharp outline. This is the beginning of the change. To understand it, it helps to remember something from the last part. Felt time depends on awareness, attention, memory, and the brain's ability to keep building a coherent present. When you are fully awake, that system works continuously. You know where you are in the flow of the evening. You know whether 5 minutes or 30 minutes have passed. You can listen, reflect, anticipate, and keep yourself mentally anchored to the world. But as sleep approaches, those abilities do not vanish in an instant. They gradually weaken. Awareness becomes less stable. Attention becomes harder to hold. Memory becomes less reliable. The self, which felt so solid a few minutes earlier, begins to blur at the edges. And that blurring is everything. Because what we call wakefulness is not just being alive with your eyes open. It is a very particular organization of consciousness. The senses are relatively synchronized. The world feels continuous. Your thoughts mostly belong to a single thread. Your sense of being, me, here, now, remains intact enough to make ordinary life possible. Sleep begins when that organization starts to loosen. One of the first things to change is attention. During the day, attention can still wander, but it usually remains tethered to the waking world. A sound pulls you back. A sensation in the body pulls you back. A thought about tomorrow pulls you back. You may drift, but you remain tethered. As you fall asleep, the tether weakens. External sounds no longer command the same response. The room becomes less vivid. The stream of thinking becomes more disjointed. This is why people often experience those strange fragments right before sleep, little flashes of image or feeling that make no ordinary sense. A familiar face may appear for a second, a random scene, a floating sentence, a place you have never been. They come and go without the usual logic of waking thought. These are often called hypnagogic experiences, and they are one of the clearest signs that awareness is changing shape. Hypnagogia is a beautiful word for a strange place. It refers to the transitional state between wakefulness and sleep, and almost everyone has visited it, even if they did not know its name. It is that in-between territory where reality and dream begin to overlap. You are not fully asleep. You are not fully awake. You are suspended in a threshold where the mind is still partially aware of the world, but already beginning to produce the kind of loose, image-rich material more common in dreams. This is why people sometimes feel as though they have started dreaming before they were even asleep. In a strict sense, full dreaming is more complicated than that, but the experience is real. The mind is beginning to slip free from its ordinary discipline. The guardrails weaken. Images arise with less effort. Thoughts stop needing to make sense. Sometimes this transitional state is gentle and almost pleasant. A person feels themselves drifting through soft imagery, perhaps hearing fragments of imagined sound, or sensing the beginning of a dream without fear. At other times, it can be abrupt or unsettling. A sudden sensation of falling. A sharp sound that is not really there. A jolt in the body that pulls someone awake again just as they were slipping under. That falling sensation, which many people know well, is especially interesting. It often comes with a sudden muscle twitch, as though the body itself were startled by the mind's descent into sleep. The exact reason is still debated, but the experience reveals something important. Falling asleep is not always seamless. It is an active neurological transition, and sometimes the systems involved do not hand things over perfectly smoothly. Still, on most nights, the passage is quiet. The brain begins reducing its engagement with the outside world. The sensory system does not shut down all at once, but it becomes less dominant. This matters because waking consciousness depends heavily on a continuous stream of incoming information. You are here because the room keeps arriving through sight, sound, touch, balance, temperature, and all the little signals of ordinary embodiment. The world keeps reminding you that you are in it. As you fall asleep, that reminder grows faint. The thalamus, which helps relay sensory information to the cortex, begins changing how it handles incoming signals. The sleeping brain does not stop receiving all information from the world, but it becomes far less responsive to it. Sensory input loses priority. Internal processes begin to take over. The brain becomes less interested in reporting the room to you in real time. This alone has profound consequences for awareness. Because one of the ways waking consciousness maintains itself is by constantly updating its model of the present. Here is the room. Here is the body. Here is the sound outside. Here is the passage of time. Here is the continuity of self. As long as those updates keep coming, the present stays coherent. But when those updates weaken, the coherence of the present begins to soften too. There is another change happening at the same time, and it may be even more important. The waking mind is very good at maintaining narrative continuity. By that I mean the simple, quiet sense that one thought follows another, that one moment connects to the next, that the self remains the same observer moving through time. As sleep approaches, this narrative continuity becomes unstable. This is why thoughts before sleep can become so peculiar. You may begin with something ordinary, a memory from the day, perhaps, or a plan for tomorrow. Then suddenly the thought turns sideways. You are no longer planning in a logical way. You are half imagining, half drifting. One idea blends into another without warning. The disciplined editor in the mind becomes drowsy. Associations loosen. The difference between thinking and dreaming begins to blur. This change is deeply tied to the fading of reflective awareness. In full wakefulness, a part of you is quietly monitoring your own mind. It notices whether something makes sense. It notices whether a memory is accurate, whether a thought is relevant, whether a plan is coherent. As sleep comes on, that self-monitoring weakens. The mind becomes less strict with itself. And when the mind becomes less strict, consciousness begins to change its character. This is an important point, because it helps explain why time starts to behave differently even before full sleep has arrived. The ordinary sense of time depends not just on being conscious, but on having a certain kind of consciousness. one that is organized, reflective, outwardly anchored, and capable of tracking sequence. As that structure fades, so does your grip on duration. You can see this even in the ordinary experience of dozing off. A person may lie in bed convinced they are still awake, only to discover that some chunk of time has already passed. 5 minutes. 10. Sometimes more. They remember lying there, and then suddenly realizing they were closer to sleep than they thought. This happens because awareness during the onset of sleep is often patchy. It can lose continuity before it disappears completely. And patchy awareness is terrible at tracking time. One reason for this is memory. The waking mind usually leaves a trail behind it. Even if you are relaxed, distracted, or quiet, your experience tends to leave some sequence of recall. You remember this thought, then that sound, then rolling over, then checking the clock. It is not always vivid, but it gives the evening a sense of shape. During sleep onset, that trail begins to break. Moments stop being recorded clearly enough to stitch into a narrative later. Without a clean record, time becomes hard to reconstruct. If awareness weakens and memory weakens at the same time, then even a short transition can later feel like a gap. The brain cannot fully replay how it crossed the boundary, because the crossing itself was only dimly registered. This is one reason falling asleep is so mysterious in retrospect. You can rarely point to the exact instant it happened, not because there is no transition, but because the very faculties needed to witness it clearly are the ones being altered. It is a little like watching a candle go out while your own vision slowly blurs. By the time the flame is gone, you are no longer seeing sharply enough to say exactly when it vanished. There is something wonderfully humbling about that. We spend so much of waking life assuming that awareness is firm and central, yet every night we are reminded that it is contingent. It can thin, it can loosen, it can slip away without drama. And as it does, the familiar structure of time goes with it. This brings us to the question of consciousness itself. What exactly is fading when you fall asleep? The answer depends on what layer of consciousness we mean. Wakefulness is not a single substance. It is made of many overlapping capacities: sensory awareness, self-awareness, attention, working memory, reflective thought, orientation in time and place, the sense of agency, the feeling of being a continuous self. These things usually arrive together, so we treat them as one. But sleep onset reveals that they can separate. You may still hear the room, but no longer care about it. You may still have thoughts, but they no longer behave logically. You may still have a vague sense of self, but it is softer, less defined. You may still be conscious in some minimal sense, yet no longer able to track time in the way ordinary wakefulness allows. Consciousness, then, is not simply present or absent. It changes configuration. And perhaps the most delicate shift of all is the fading of self-location. By self-location, I mean the feeling that you are clearly and stably here, in this bed, in this room, in this sequence of the night. In full wakefulness, that feeling is effortless. You know where you are in space, in time, and in your own biography. Sleep onset gently unthreads that certainty. It does not always happen dramatically. More often it happens with astonishing softness. The body grows heavy. The room becomes vague. The importance of the next day recedes. The sense of being a person managing an evening gives way to something quieter, less verbal, less defined. This is why the transition into sleep can feel almost sacred when noticed calmly. Not in a mystical sense, necessarily, but in the sense that it reveals how much of your ordinary self depends on active mental maintenance. The waking self is not a permanent object. It is a dynamic arrangement. Every night, it loosens. Every morning, it returns. And in the middle, the world continues without requiring your awareness to supervise it. Your heart continues. Your breathing continues. Your circadian rhythms continue. Your brain continues shifting through stages. But the waking self, the one who tracks, organizes, and narrates, recedes. That recession is the key to the disappearance of time in sleep. Because time, as lived by a human being, is not merely the passage of external events. It is the passage of those events through an organized field of awareness. When that field becomes thin, unstable, or absent, duration loses its familiar form. This is also why sleep is such a close cousin to anesthesia, though not identical. Under anesthesia, people often report an almost total absence of time. One moment the mask is on, the next moment they are in recovery. It feels as though no journey occurred between those points. Sleep is not the same physiological state, but dreamless sleep often produces a similar effect. Time passes physically, but awareness did not remain continuous enough to feel its passage. That continuity is everything. And in falling asleep, continuity is precisely what begins to fail. The transition itself is especially elusive because the brain is moving from one mode to another while the observer is being dimmed by the very process it is trying to observe. It is a little like trying to watch yourself disappear. Some people come surprisingly close to noticing it, especially those who meditate regularly or spend time lying still without fighting the approach of sleep. They sometimes report noticing the exact way thoughts become less verbal and more image-based, the way bodily boundaries soften, the way ordinary mental effort becomes impossible to sustain. But even then, there is often a point where observation itself gives way. The watcher cannot follow the process indefinitely, because the watcher is part of what is changing. That may be the most intimate mystery in all of this. You do not merely go into sleep. The very part of you that could narrate the entry is what sleep is taking. And so the handoff is never fully remembered from the inside. If this slow exploration is helping you unwind, and you enjoy these kinds of calm journeys through science and consciousness, you can gently subscribe, leave a like, or later share in the comments what falling asleep feels like to you. Some people describe it as drifting, some as slipping, some as fading, and some as barely noticing it at all. It is one of those universal human experiences that still feels strangely personal. Now, from a scientific point of view, the transition into sleep is often described as the movement from wakefulness into the earliest stage of non-REM sleep, sometimes called N1. This is the threshold stage, the lightest form of sleep, where the brain begins departing from the rhythms of waking rest and moving toward a different pattern altogether. It is not yet deep sleep, not yet the blankness that erases hours, but it is the doorway. People awakened from this stage often say they were not truly asleep. That is part of what makes it so fascinating. Awareness is already altered, yet the person may still feel close enough to wakefulness to deny having crossed over. This tells us that sleep onset is not a sharp line in subjective experience. It is gradual enough to be disputed by the person undergoing it. That alone shows how unreliable felt continuity can be. A person may feel they stayed awake the whole time, yet brain activity suggests otherwise. Another may feel they fell asleep instantly, though the transition took longer than they realized. The subjective story and the physiological story do not always match. Once again, real time and felt time begin parting company. And all of this prepares us for what comes next. Because the fading of awareness at sleep onset is only the beginning. Once consciousness loosens enough, the brain enters states where time is not just hard to track, but almost impossible to experience in the ordinary way. The observer has dimmed. The sensory world has withdrawn. Memory has begun to fail. The waking narrative has broken. What follows is the remarkable territory of sleep itself. Sometimes blank, sometimes dream-rich, sometimes so deep and quiet that the night seems to vanish altogether. And that leads us naturally to the next part of the journey. Because once awareness has faded enough, a new question takes its place. What does the deepest part of sleep feel like from the inside? Or perhaps the better question is this: can it be said to feel like anything at all? That is where the mystery becomes even more profound. Because deep sleep does not merely change consciousness. It seems, in some important sense, to empty it. Part 5. Why deep sleep feels almost timeless. If falling asleep is the soft fading of awareness, then deep sleep is what comes after the fading is complete. It is the quietest part of the night, not always the longest part, not the most vivid, not the most dramatic, but perhaps the strangest. Because deep sleep is one of the only experiences human beings have over and over again where time can seem to disappear almost entirely. You lie down. You drift through that loose and uncertain threshold where thoughts begin to blur. You pass through the shallow edges of sleep. And then, somewhere beyond what you can consciously follow, you enter a state so dark, so still, and so empty of ordinary experience that when morning comes, it can feel as though you simply stepped across a gap. This is why deep sleep feels timeless. Not because time in the universe has changed. Not because the night has physically shortened, but because the machinery that usually turns passing time into lived experience has fallen almost completely silent. That is the heart of it. The world continues. The earth keeps turning. The room cools or warms. The night outside moves toward dawn. Your body continues its quiet work. But from the inside, deep sleep often leaves almost nothing behind. No continuous sequence. No stable awareness. No internal commentary. No detailed memory of having passed through it. And where there is no sustained awareness, there is usually no felt duration. That is why deep sleep is so different from lying awake in bed. When you are awake, even if you are resting, there is still an observer present. You can hear the room. You can think about the day. You can notice the weight of the blanket, the sound of the fan, the faint ache in your neck, the passing of a few minutes. Even if you are doing very little, your mind is still there to witness the interval. In deep sleep, that witness seems to withdraw. It is not just quieter. It is absent in the ordinary sense. And without that witness, time no longer feels like something moving past you. It no longer feels like anything at all. This is one of the reasons deep sleep can feel so mysterious when we try to think about it. Dreaming gives us something to hold on to. A place, a story, an image, a strange emotion, a memory fragment. Even light sleep sometimes gives us flashes of experience. But deep sleep often gives us almost nothing. It is not a place we remember visiting. It is more like a blank seam in the fabric of the night. And blankness has a peculiar relationship with time. If you look back on an experience full of events, it tends to feel extended. There were things in it. Markers. Shifts. Scenes. But if you look back on something that left almost no internal record, your mind has very little to reconstruct. The interval becomes hard to inhabit in memory. It is not replayed as a long passage. It is simply absent, and the absence compresses. That is why deep sleep can feel almost like teleportation. One moment, you are still vaguely aware of the night. The next, the alarm is sounding. And what lies between those points often has no texture at all. To understand why, we need to gently enter the physiology of deep sleep itself. Sleep is not a single uniform condition. It unfolds in cycles, moving through different stages with different patterns of brain activity. Deep sleep is part of non-REM sleep, especially what is often called slow-wave sleep. It gets that name because the brain's electrical activity begins to show large, slow oscillations, sweeping rhythms that are very different from the faster and more varied activity of waking consciousness. Those slow waves are important. They tell us that the brain is operating in a very different mode, one less suited to the constant, detailed, flexible awareness of waking life. Neurons across large regions of the cortex begin shifting together between active and quiet phases, almost like a great field of lights slowly pulsing on and off. This is not the signature of a brain-building rich conscious experience moment by moment. It is the signature of a brain in a deeply restorative state. Deep sleep is not empty because nothing is happening. It is empty because what is happening is no longer aimed at producing ordinary conscious awareness. That distinction matters. Sometimes people imagine deep sleep as a kind of shutdown, as though the brain simply powers off. But that is not really what happens. In some ways, the brain is very busy during deep sleep. It is regulating the body. It is helping support immune function. It is involved in memory consolidation. It is maintaining essential rhythms. Hormones shift. Repair processes unfold. Metabolic work continues. The body is not absent from the night. It is deeply engaged with it. What changes is the style of brain activity that supports the feeling of being an awake self located in a flowing present. That style weakens so much that the mind stops constructing the kind of internal scene that would let duration be consciously experienced. Think back to the earlier parts. Felt time depends on attention, memory, sequence, and a stable observer who can inhabit one moment after another. Deep sleep weakens or removes all of those ingredients at once. Attention is no longer directed outward or inward in the usual way. New experience is not being tracked with waking clarity. Memory formation, at least for the subjective experience of the moment, is largely absent. And the observer, the familiar I, who normally sits at the center of things, is no longer there in any robust form. When all of that falls away together, time loses its psychological substance. It still passes, but it is no longer being lived as passage. That is the crucial difference. There is a useful comparison here, and it is one many people understand immediately. General anesthesia often feels similar in one narrow but important way. People go under, and then they wake. Hours may have passed physically, but there is no inner sense of those hours having unfolded. They do not feel long. They do not feel short. They simply do not feel present in memory as experience. Deep sleep is not the same thing medically or neurologically, of course. It is a natural and cycling state, not a chemically induced interruption. But from the point of view of felt duration, there is often a family resemblance. In both cases, the bridge of conscious continuity breaks. And when continuity breaks, time is not experienced as an unbroken river. It becomes a missing section. This tells us something profound about the human mind. We often assume that time is something we simply sit inside, the way a fish sits inside water. But deep sleep suggests something else. It suggests that much of what we call time in lived experience is not merely there waiting for us. It has to be constructed, not invented from nothing, but actively assembled from awareness, sequence, and memory. When the construction process stops, the world does not stop, but the experience of time largely vanishes with it. This is one reason deep sleep can feel almost sacred in retrospect. Not because we consciously experience anything mystical there, but because it shows us just how dependent our ordinary reality is on mental activity we rarely notice. The flow of time, the stability of self, the sense of one moment leading into another, these feel so basic that we mistake them for permanent features of existence. Deep sleep gently reveals that they are, at least in part, achievements of consciousness. And consciousness is not always on duty. There is something calming in that. Every day, the mind is busy. It sorts, worries, predicts, remembers, compares, organizes. It tracks deadlines, replays conversations, anticipates tomorrow, notices time slipping away. But in deep sleep, all that softens into near nothingness. The self that normally carries the burden of the day is relieved of its post. For a while, no narrative has to be maintained. No future has to be imagined. No past has to be arranged into meaning. There is just the organism, breathing in the dark, held inside rhythms older than thought. Perhaps this is part of why people crave good sleep so deeply. It is not only rest for the body. It is temporary relief from the need to be a continuously conscious self. Deep sleep offers a kind of suspension, not of life, but of self-monitoring. And because self-monitoring is so closely tied to felt time, the result is that the night seems to collapse. It is worth noticing, too, that deep sleep is not spread evenly across the whole night. It tends to be more prominent earlier in the night, especially in the first few sleep cycles, when the body is under the strongest pressure for restoration. Later in the night, REM sleep often becomes longer and more frequent. That means the first part of the night is often where the deepest timelessness lives. You do not usually know when you enter it. You do not usually know when you leave it. That alone is remarkable. Imagine any other state you enter regularly without being able to consciously track its beginning, inhabit its middle, or clearly remember its end. Deep sleep is like that. It is a major portion of human life, and yet from the inside it often leaves only a silence. This silence has led thinkers, philosophers, and spiritual traditions to wonder about deep sleep for centuries. What is a person in dreamless sleep? Is consciousness absent, or simply stripped of objects? Is there no experience at all, or just no memory of experience? Science, for the most part, remains careful here. It can measure brain states, responsiveness, and later recall. It can say that ordinary awareness and reportability are dramatically reduced. But whether there is some faint residue of experience with no memory attached is a more difficult question. For the purposes of our topic, though, one thing is clear enough. Deep sleep, as it is later remembered, feels timeless because it leaves almost no experiential structure for the mind to retrieve. And retrieval matters more than we might think. When you wake up and try to understand how the night passed, you do not consult the night directly. You consult traces, memories, fragments, continuity. If those traces are rich, as in dreaming, the night may feel full. If those traces are thin, the night may feel short. If those traces are almost absent, the interval can feel like a blank instant. In that sense, timelessness is often what an unrecorded interval feels like in retrospect. Not eternal, not magical, just unmarked. Think about how different that is from wakefulness. During a normal waking hour, even a quiet one, the mind gathers impressions constantly. The feeling of the chair, a passing thought, a sound outside, a flicker of emotion, the movement of light on a wall, a decision to shift position. These all create a subtle texture. Even if you do not remember every detail, they help time feel inhabited. Deep sleep removes the texture. And once the texture is gone, the interval becomes hard to experience as duration at all. There is also a strong contrast between deep sleep and insomnia, and this contrast may be the clearest demonstration of all. A person who lies awake at night often becomes acutely aware of time. The clock becomes an enemy. Every half hour feels measurable. The night stretches. Fatigue combines with frustration, and time thickens into something almost oppressive. Why does it feel so long? Because awareness remains active. The observer is still present. Attention keeps returning to the passage of time. Thoughts continue. Memory continues. Self-consciousness continues. The very ingredients that vanish in deep sleep are painfully active in sleeplessness. So on one side, insomnia magnifies time by keeping the observer awake. On the other side, deep sleep erases time by letting the observer disappear. These are opposite experiences, yet together they reveal the same truth. Felt time depends on the style and intensity of consciousness. The world's clock does not explain either experience by itself. There is another subtle point here, one that many people overlook. Deep sleep does not just feel like nothing because you are unconscious. It feels like nothing partly because your brain is not building the kind of narrative continuity that would let you later say, "I was there while those hours passed." The waking self returns in the morning and finds a gap, and the gap gets interpreted as timelessness. This can be almost shocking after very good sleep. You close your eyes while still aware of the room, and then suddenly light is pressing around the curtains. Morning is already in progress. If the sleep was deep enough, the jump can feel almost impossible, as though the night had no internal width at all. You know intellectually that hours have passed, but your experience does not feel stretched across them. This creates one of the most intimate contradictions in everyday life. You know the night was long, but it does not feel long. That contradiction is only resolved once we accept that real time and felt time are doing different things. Real time is counted by clocks and by physical change. Felt time is counted by experience, and deep sleep gives experience almost nothing to count. If this gentle kind of thinking is helping you drift a little deeper into calm, you can always support the channel with a quiet like or subscribe when you feel like it. And if you ever wake from a night of especially deep sleep and feel that strange sense of having skipped across darkness in a single step, you're not alone. It is one of the most ordinary and most mysterious experiences we share. Now, deep sleep is also deeply restorative, and that restoration may itself help explain why it is so inwardly silent. When the brain enters slow-wave sleep, many systems seem to shift away from external responsiveness and toward maintenance, recalibration, and consolidation. The priority is no longer to produce a rich conscious world. The priority is to support the organism more fundamentally. That may be one reason why waking someone from deep sleep often feels difficult and disorienting. The brain is far from the alert, integrated mode required for ordinary awareness. A person pulled from deep sleep may feel confused, heavy, slow, even briefly lost. This grogginess is sometimes called sleep inertia, and it reveals how unlike wakefulness deep sleep really is. The brain is not hovering just beneath ordinary consciousness. It is operating in a substantially different state. And this state, precisely because it is so different, does not lend itself to clear experience of passing time. One way to imagine it is like this. Waking consciousness is a lantern moving steadily through the dark, lighting one section of the path after another. Deep sleep is what remains when the lantern is set down and the path continues without illumination. The path is still there. The night is still moving, but no one is lighting the steps. And so, when the lantern is picked up again in the morning, the unlit stretch behind you feels like a single dark fold. This is why dreamless sleep has such a different emotional tone from dreaming. Dreams, even strange or fragmented ones, belong to the theater of the mind. There are scenes, feelings, images, often some bizarre sense of movement or story. But deep sleep has almost no theater. It is not an alternate world. It is the near absence of world. That near absence is exactly what gives it its timeless quality. Because duration, psychologically speaking, is easiest to feel when something is there to carry it. A scene carries it. A thought carries it. A self carries it. A sequence carries it. Deep sleep carries almost nothing of the kind. And so time, though still physically present, becomes psychologically weightless. This may also be why people sometimes speak of very deep sleep with unusual tenderness. They say they were out, or that they slept like nothing. Those phrases are simple, but they point to something profound. Deep sleep can feel good partly because it removes not just fatigue, but temporal burden. You are no longer moving minute by minute through worry, anticipation, or effort. You are simply absent from that entire mode of being. In a culture so dominated by schedules, deadlines, and forward motion, that kind of absence may be one of the purest forms of relief available to the mind. And yet, for all its silence, deep sleep does not tell the whole story of the night. Because the sleeping mind does not remain blank from dusk until dawn. It cycles. It rises and falls. It deepens and lightens. It disappears into slow-wave quiet and then returns to stranger, more vivid forms of internal life. And that means the timelessness of deep sleep is only one half of the mystery. The other half is dream time. Because once the mind leaves the blankness of deep sleep and begins dreaming more vividly, especially in REM sleep, something extraordinary happens. Time, which had seemed to vanish, starts to return. But it does not return in the neat, measured form of waking life. It comes back elastic, distorted, narrative, strange. A few minutes can feel like a journey. A short REM period can seem like a long unfolding. And that raises the next question. If deep sleep erases time by removing the observer, why do dreams sometimes seem to stretch time into whole stories? Why does the mind, after emptying itself so completely, come back not into ordinary sequence, but into something far stranger. That is where we go next. Because the timeless void of deep sleep is only the quiet middle chamber of the night. Beyond it, the theater begins again. And in that theater, time does not disappear. It bends. Part 6. Why dreams can feel long, even when they are not. There is a strange kind of time that only exists in dreams. It is not the time on your phone screen, or the time on the kitchen clock, or the time measured by the slow turning of the earth in darkness. It is something softer, stranger, and much harder to pin down. A dream can begin in an instant and yet seem to contain an entire journey. You may walk through a city, speak to people you have not seen in years, cross landscapes that do not exist, lose something precious, find it again, and wake with the feeling that a long story has just unfolded. And then you look at the clock. Perhaps only 20 minutes have passed, or 15, or less. This is one of the most fascinating things about sleep. Deep sleep often feels almost timeless because it leaves us with so little experience to remember. But dreams do something very different. They seem to give time back to us, though not in its ordinary shape. They do not restore the measured, reliable flow of waking life. They create a private kind of time, a subjective time, elastic and theatrical, where moments can stretch, collapse, loop, fragment, and rearrange themselves in ways that would feel impossible when awake. That is what we are exploring now. Why can dreams feel long, even when they are not? Why can the mind create the feeling of an extended narrative in such a short interval of real time? And what does that tell us about the way consciousness builds time in the first place? The first thing to say, gently and clearly, is that dreams do not prove that time physically changes during sleep. The night outside the dream remains faithful to clocks. The body remains inside the same physical universe. If 20 minutes pass in the bedroom, 20 minutes pass in the dreamer's body as well. The strange part is not the physics. The strange part is experience. Dreams reveal, perhaps more clearly than any other ordinary human state, that the felt length of an event and the measured length of an event are not the same thing. And once you understand that, dream time begins to make a different kind of sense. When we are awake, our sense of duration is tethered to a fairly stable world. There are external cues. The room remains coherent. Sound behaves normally. Gravity behaves normally. Cause and effect usually make sense. One event leads into another in a sequence that the waking mind can track with some reliability. Even if time feels fast or slow depending on mood, the world gives us a shared frame. Dreams remove that frame. Inside a dream, the mind is no longer taking its main cues from the outside world. It is building scenes from within. It draws on memory fragments, emotion, expectation, imagination, bodily signals, and whatever else the sleeping brain is weaving together in the dark. Without the steady anchor of waking reality, time becomes far more vulnerable to distortion. But that distortion is not random. It has patterns. One reason dreams can feel long is that they often create the impression of narrative depth without actually containing every step of a long sequence. A dream does not always unfold like a camera recording every second. Often it behaves more like a story that begins in the middle of things. You are suddenly already somewhere, already in conversation, already late, already running, already in a house you somehow recognize, though you have never seen it before. The dream drops you into a situation already loaded with meaning. This is important, because in waking life, a long experience usually feels long partly because it contains many transitions. You leave one room, walk to another, wait for someone to arrive, listen, respond, travel, observe, remember. But in dreams, the mind can suggest the weight of a long experience without needing to simulate every bridge between moments. It can imply a backstory instantly. It can make you feel that something has been going on for hours without showing you those hours in any literal way. In that sense, dream time is often efficient. It cheats, but elegantly. A dream may give you the emotional impression of a whole afternoon, a whole journey, even a whole relationship, by presenting you with the feeling that these things already exist. The mind accepts the scene and its meaning at once. You do not ask, in the dream, how you got there, how long you have known these people, or why the logic is incomplete. The dream supplies a sense of temporal thickness without needing all the real-time structure of waking life. That alone explains a great deal. A dream can feel long because it conveys the meaning of length, the emotional weight of length, the narrative suggestion of length, even when the actual sequence is brief. Think of how a novel can summarize 10 years in a paragraph, yet still make those 10 years feel real to the reader. Dreams can do something similar, though more suddenly and more intimately. They are not always showing you every minute. They are often giving you the felt shape of a larger story. This is why dreams can feel both brief and vast at the same time. Brief in their actual construction, vast in their implication. There is another reason as well, and it has to do with memory. Dreams often recruit fragments of waking memory and stitch them together at unusual speeds. Faces from long ago appear beside places from last week. A childhood home opens onto a train station. A friend speaks with the voice of a parent. An argument from years ago merges with a current anxiety and becomes a new scene altogether. The dreaming mind is a remarkably fast editor. It does not build from scratch in the same careful way waking reason does. It assembles, blends, compresses, and jumps. This can create the feeling that a great deal has happened. A dream may feel dense not because it lasted so long in real time, but because it carried so many associations, so many emotional signals, so many pieces of memory compressed into one inner event. The richer and more layered the dream, the more spacious it may feel in retrospect. This helps explain an odd contrast. Two dreams of equal real-world duration may feel very different in length. One may feel like a quick, almost meaningless fragment. The other may feel like an entire chapter of a life. The difference often lies not in clock time, but in density. Emotional density, narrative density, memory density, symbolic density. Waking life has this quality too, in milder form. A dull, repetitive hour can feel short in hindsight because so little stands out from it. But an hour filled with surprise, emotion, novelty, or danger can feel much fuller when remembered. Dreams seem to amplify this principle. A short REM period can feel long if it contains enough internal richness. There is something else happening in dreams that deserves attention. When you are dreaming, especially vividly, you are often no longer checking time. This may sound simple, but it matters. In waking life, the mind sometimes monitors duration directly. It asks how long this has taken. It notices the clock. It compares expectation with reality. That monitoring helps build a certain kind of measured experience. In dreams, that habit is usually absent. The dreamer is inside the scene, not outside it with a stopwatch. Time is being lived, not counted. And without counting, duration becomes freer to follow narrative and emotion instead of clock-like sequence. A frightening moment in a dream can stretch because it feels intense. A chase can seem extended because the mind remains trapped in its urgency. A conversation with someone lost or loved can feel deeply spacious because the emotion in it is so concentrated. The dream does not need to justify its pacing to the waking intellect. It follows its own laws. This is one reason dream time can seem more like the time of stories than the time of physics. Stories do not always move second by second. They linger where meaning lingers. They skip what does not matter. They repeat certain motifs. They bend chronology for emotional truth. Dreams often behave like that. They are not trying to be clocks. They are trying, perhaps, to be experiences. This is especially clear when a dream seems to contain a whole world that feels older than the dream itself. You may enter a place in a dream and immediately feel that you have been there before, or that you belong there, or that some unspoken history is already underway. That sense of background can make a dream feel long before anything much has even happened. It gives the dream gravity. The mind creates not only a scene, but the shadow of a past behind the scene. And that shadow is enough to make a brief dream feel like part of something much larger. Now, there is an interesting scientific question underneath all this. Do dreams actually unfold much faster than waking life, or do they mainly feel longer because of how they are remembered? The answer seems to be somewhere in the middle. Some dream experiences, especially simple actions, appear to map surprisingly closely onto real time. This became clearer through studies of lucid dreamers, people who know they are dreaming and can sometimes signal from within the dream using deliberate eye movements. Because the muscles controlling the eyes are not paralyzed in quite the same way as much of the rest of the body during REM sleep, lucid dreamers can sometimes perform agreed-upon eye signals that researchers can measure. These studies are fascinating because they let scientists compare dream actions with waking actions in a rough but meaningful way. When lucid dreamers count or perform certain simple mental tasks in dreams, the timing can be fairly close to waking time. That tells us dream time is not simply endless or wildly detached from the body. It still unfolds in relation to real physiological processes. The dream is not occurring in some separate universe where hours fit into seconds without limit. But other tasks, especially those involving movement, can become slower or stranger in dreams. Running may feel heavy. Speaking may feel elongated. Trying to perform physical actions can feel effortful in ways that distort duration. That makes sense when you remember that the dreaming brain is generating the experience internally without the normal feedback loops of waking movement. It is simulating action, not carrying it out in the usual way. This mixture is important. Dreams are not pure fantasy in their timing, nor are they simple mirrors of waking time. They occupy an in-between territory. Some parts seem to track real duration reasonably well. Other parts bend according to emotion, narrative implication, missing transitions, and the altered logic of the dreaming brain. It is also worth remembering that when we wake from a dream, we do not retrieve it perfectly. We reconstruct it. We gather fragments very quickly before they dissolve. In that reconstruction, the dream may take on a sense of length that was partly present in the dream and partly supplied in waking recall. The memory of a dream is often unstable, yet emotionally convincing. You may wake with the certainty that you have been immersed in something vast, even if only certain scenes remain accessible. So in some cases, the feeling that a dream lasted a very long time may arise partly from the dream itself and partly from the waking mind's interpretation of it. The mind wakes, sees all this emotional residue and narrative implication, and concludes, that must have been long. And in a psychological sense, maybe it was. This is one of the quiet difficulties in talking about time. When we ask how long something was, we may be asking more than one question at once. We may mean how long it lasted by the clock, or we may mean how large it felt, how much meaning it carried, how much inner space it occupied. Dreams often score very differently on those two measures. There is another layer here that makes dreams feel long, and it has to do with the absence of ordinary transitions. In waking life, the transitions between events take time and effort. You get dressed. You walk downstairs. You leave the house. You wait at a crossing. You enter a building. Physical life is full of intervals between one meaningful thing and the next. These intervals help shape our sense of real-world duration. Dreams often remove or compress those intervals. You can be in one place, and then another. One moment in childhood, the next in a future that does not exist. One sentence can turn the scene completely. Time is not spent in the same way because movement between states is so fluid. Yet paradoxically, this can make dreams feel larger, not smaller, because more seems to happen per unit of real time. It is as though the dreaming mind edits out the hallway and keeps only the rooms. That makes for a strange kind of spaciousness. The dream becomes a sequence of charged moments, each carrying more symbolic or emotional weight than a normal waking moment might. And when you look back on several such moments, the mind reads them as extended. In other words, dreams can feel long partly because they are so concentrated. And concentration of meaning can mimic duration. A few emotionally saturated scenes can feel like an entire arc of experience. A short REM period can feel like a whole journey because dreams are efficient at extracting the emotionally significant parts and leaving out the ordinary temporal scaffolding that would usually connect them. This also helps explain why dreams can sometimes feel older than they are. You may wake with the feeling that a dream belonged to some much longer process, that it had roots, that it had been going on before you entered it, that it continued somehow after you woke. This is because dreams often do not present themselves as brand new events. They present themselves as slices of already meaningful worlds. And worlds always seem older than moments. There is also the chemistry of REM sleep to consider, though we can keep this gentle. During REM sleep, the brain becomes highly active in some ways, yet not in the ordinary balanced way of waking consciousness. Visual and emotional regions can be very active. The brain is capable of vivid imagery, strong feeling, and surprising associations. At the same time, the systems that usually support critical reflection and orderly reasoning are less dominant. That means dreams can feel intense and convincing without being carefully checked for coherence. This matters because critical reflection is one of the things that might normally question impossible time. In waking life, if you suddenly felt you had lived through 3 days in 20 minutes, your reflective mind would object. It would start measuring, comparing, correcting. In dreams, that corrective system is weaker. The dream can simply declare, by feeling, that a long interval has unfolded, and the dreaming self accepts it. That acceptance is powerful. It allows dream time to feel valid from within, even when it would seem absurd from outside. And that tells us something quietly profound about consciousness. Much of what we accept as temporal reality depends not only on duration itself, but on the brain's willingness to believe its own construction. When awake, the brain cross-checks more carefully against the world. When dreaming, it cross-checks less. The result is a more fluid sense of time. If you have ever had a dream that felt as if it lasted for years, or a dream in which a whole relationship seemed to exist, or a dream in which a brief scene somehow carried the emotional weight of a life stage, then you already know how persuasive this can be. The dream does not merely show you content. It gives you the feeling of time invested in that content. That feeling can linger after waking. Sometimes it lingers so strongly that the waking world feels thin for a few seconds by comparison. You open your eyes and are surprised by the room, as though you have returned from much farther away than a single sleep cycle should allow. That is one of the signature experiences of dream time, the sense that you were away longer than the clock can account for. And yet, the clock is not wrong. The dream is simply operating in another register of experience. This is why dreams are so revealing for the larger question of this whole video. They show that the mind does not merely receive time like a passive container. It helps shape time as lived. It can erase it in deep sleep. It can stretch it in dreams. It can compress it in routine. It can magnify it in fear. The clock outside remains steady, but the clock inside is much more like an instrument being played. Perhaps that is why dreams have fascinated people for as long as human beings have told stories. They make visible something usually hidden, the plasticity of experience itself. They remind us that consciousness is not a simple mirror of reality. It is a maker of worlds. And worlds, even inner ones, carry their own sense of time. If this calm kind of exploration is carrying you along tonight, you can gently like the video, subscribe to the channel, or leave a comment later about the strangest dreamtime experience you've ever had. Many people have had dreams that felt impossibly long, and there is something comforting in how universal that strangeness really is. Now, before we close this part, let us gather the thread. Dreams can feel long even when they are not, because the mind is no longer measuring time the way waking consciousness does. It is building felt duration from other materials, from narrative implication, from emotional density, from compressed memory fragments, from missing transitions, from acceptance of impossible continuity, from the strange freedom of a brain no longer anchored to the external world in the same way. A short dream can feel like a long experience because it contains the shape of one. It contains the emotional architecture of one. It contains enough depth, enough association, enough inward movement, that the waking mind later treats it like something much larger than the minutes that held it. So dream time is not false. It is simply a different kind of truth. Not the truth of clocks, but the truth of inner experience. And once we see that, the next step becomes natural. Because if dreams reveal how elastic subjective time can be, then we have to ask what in the body helps stabilize time at all. What keeps our days and nights from becoming completely unmoored? What gives the organism its larger rhythm beneath all this shifting experience? That brings us out of the dream and back into the body itself. Back to the deeper timing systems that continue their work whether you are awake, asleep, dreaming, restless, or still. Back to the quiet biological architecture beneath your nights. Because beyond the strange theater of dreamtime, another clock has been ticking the whole time. Not on the wall. Inside you. Part 7, the body clock, circadian rhythm, and the night. If dreams show us how flexible time can feel, the body clock shows us something equally important. Beneath all the strange softness of sleep, beneath the disappearing hours of deep sleep and the elastic stories of dreams, there is still a rhythm holding everything together. A rhythm older than your thoughts, older than your plans, older even than the version of you who lies awake at night wondering what time it really is. Because while your conscious experience of time can blur, stretch, compress, or vanish, your body is still keeping its own kind of order. Quietly, faithfully, all through the night. This is where the story becomes beautifully grounded again. We have spent several parts talking about how time can seem to disappear in sleep, and how the mind can distort duration so completely that a few minutes may feel like a journey, or 8 hours may feel like a single step across darkness. But none of that means the body has become untethered. Quite the opposite. Sleep is not chaos. It is deeply structured. It is guided by cycles, hormones, temperature shifts, neural timing, and biological expectations that have been shaped over millions of years. And at the center of that great nightly order is something so quiet and so small that you could easily miss its significance. Your body clock. Most of us know, in a casual way, that we have one. We speak about being a morning person or a night owl. We talk about jet lag, or about feeling sleepy at a particular hour, or waking just before the alarm. We notice that some evenings our mind grows heavy almost on schedule, while other nights something feels off, as though the whole body has lost the plot. These are familiar experiences. But beneath them lies one of the most elegant systems in human biology. Inside the brain, in a region called the hypothalamus, sits a tiny cluster of cells known as the suprachiasmatic nucleus, often shortened to the SCN. The name sounds technical, but its function is wonderfully simple. It acts as the body's master clock. Not the kind of clock that counts seconds in the way a stopwatch does, but the kind that organizes the larger rhythm of day and night. It helps tell the body when it is time to be alert, when it is time to begin winding down, when hormones should rise, when temperature should fall, when sleep should become more likely, and when morning should slowly begin, even before your eyes open. This is part of what is meant by circadian rhythm. The word circadian comes from a phrase meaning roughly about a day, and that is exactly what it is. A near 24-hour biological rhythm that helps coordinate the timing of countless processes in the body. Sleep and wakefulness are only the most obvious examples. Your circadian rhythm also influences hormone release, digestion, blood pressure, body temperature, alertness, and even aspects of mood and cognitive performance. In other words, you are not just sleeping in the night. You are moving through a carefully timed biological landscape. And this matters deeply for our question about time, because it reminds us that even when consciousness becomes fragmented, even when felt time becomes strange, the body itself remains part of a larger and very orderly cycle. Sleep is not simply switching off. It is a timed event in a timed organism living on a timed planet. That sentence alone says a lot. You live on a rotating world. Light arrives and departs in a regular pattern. For most of evolutionary history, that pattern was one of the strongest facts of life. Brightness meant one set of possibilities. Darkness meant another. Hunting, resting, eating, hiding, mating, migrating, repairing, all of life on Earth had to adapt to that planetary rhythm. So it should not surprise us that the brain evolved systems to anticipate it. And anticipation is the key word. Your body clock is not merely reacting to night after it happens. It is forecasting it. It is preparing for changes before they fully arrive. That is why the body can start shifting towards sleep in the evening even before you consciously feel tired, and why it can begin moving toward wakefulness before dawn, even while you are still asleep. This anticipatory quality makes the circadian system feel almost intelligent, though of course it is better understood as exquisitely tuned biology. It is not thinking in the human sense. It is keeping time in the deep sense of life, adapting to recurring patterns. The most important signal for setting this clock is light. Light is the great environmental cue, the one that tells your biological system what part of the day it is. Special cells in the eye detect light and send signals directly toward the brain's clock system. This is why bright morning light can help anchor wakefulness, and why light late at night, especially artificial light, can confuse the body about when the night has truly begun. In a natural setting, dusk is gradual. The brightness of the world softens. Blue-rich daylight recedes. Shadows lengthen. The sky darkens slowly enough that the body can begin transitioning. But modern life often interrupts that process. We flood the evening with light, sometimes with the kind of bright, stimulating light that resembles day more than night. And the body, which evolved under older skies, has to interpret that signal somehow. This is one reason modern nights can feel so misaligned. The mind may be tired. The schedule may say it is bedtime. But the biology of light exposure may be telling a more confused story. And when the circadian rhythm is confused, sleep often becomes shallower, later, more restless, or harder to enter. There is something almost tragic in that, in a quiet way. Human beings have become so good at mastering the night externally that we sometimes forget how much of us is still built to respond to it internally. We can light a room at midnight until it feels like early evening. We can scroll, work, watch, message, plan, and continue stimulating the mind as if day need never end. But the body remains an ancient creature. It still listens to darkness. It still expects a descent. This descent is helped along by one of the most famous substances in the sleep story, melatonin. Melatonin is often spoken about as if it were a sleep switch, but it is more accurate to think of it as a time signal. It does not knock you unconscious in the way a sedative might. Instead, it helps communicate to the body that biological night has begun. As evening arrives and light decreases, melatonin secretion rises. It is part of the body's message that the conditions of night are here, that the system should begin shifting away from wakeful mode. That does not mean melatonin alone determines whether you sleep well. Sleep is more complicated than one hormone. But melatonin does help mark the night from within, and that makes it central to our topic. Because once again we see two layers of time operating together. There is external time, the clock on the wall. And there is internal biological time, the body's sense of where it is in the daily cycle. These are usually aligned, but not always. Think of jet lag. A person boards a plane, crosses time zones, and arrives in a place where the clocks say one thing but the body says another. Morning outside may feel like the middle of the night inside. Hunger comes at odd hours. Sleep arrives at inconvenient times. The external schedule and the internal schedule no longer agree. Jet lag is such a vivid example because it reveals that your sense of day and night is not simply handed to you by the local clock. It is generated by a living system that needs time to retune itself. You can change your watch instantly. You cannot change your biology quite so fast. And if that is true across oceans, it is also true in smaller ways in everyday life. Staying up very late for several nights, working shifts, exposing yourself to intense light late in the evening, or waking abruptly at inconsistent times can all tug the internal clock away from the patterns that usually support sleep. This matters because when we ask what happens to time when you sleep, part of the answer lies in the fact that sleep is not just a response to tiredness. It is also a timed event governed by circadian expectation. That expectation works together with another important process, sleep pressure. Sleep pressure is different from the circadian rhythm, though the two interact all the time. If the circadian rhythm is your internal day-night timing system, sleep pressure is more like the growing need for sleep that builds the longer you stay awake. One of the substances associated with this process is adenosine, which accumulates during wakefulness and helps make the brain more ready for sleep. The longer you are awake, the more sleep pressure tends to build. Then, during sleep, it gradually clears. This is a lovely example of how layered the body's timing really is. One process says, it is biologically night. Another says, you have been awake long enough, now sleep is needed. When those two line up well, sleep often comes more naturally. When they do not, things can feel strange. You may be exhausted after poor sleep, but your circadian system may still be trying to hold you awake in the early evening. Or you may have low sleep pressure after sleeping in late, even while the clock says it is bedtime. Or your body may be deeply ready for sleep, but late night light and stimulation may be pushing against that readiness. This dance between circadian rhythm and sleep pressure shapes much of how the night unfolds. And it shapes not only when sleep begins, but also what kind of sleep becomes more prominent at different times in the night. Earlier in the night, when sleep pressure is higher, deep non-REM sleep tends to be more prominent. Later, as sleep pressure eases and the night continues, REM periods often become longer. This means the architecture of the night is not random. The timing of different sleep stages is partly built into the way the body coordinates restoration and brain state across the whole sleep period. That is quite astonishing when you stop to think about it. The night is not a blank block of unconsciousness. It is a sequence, a repeating biological composition, a rhythm within a rhythm. You pass through lighter sleep, deeper sleep, dreaming sleep, and back again, usually several times, each cycle with its own texture. And all the while the circadian system continues guiding the larger pattern, orienting the organism within the night. This gives us a new perspective on why time can feel so strange in sleep. From the outside, the night is highly structured. From the inside, it may feel almost structureless. That contrast is one of the central wonders of sleep science. The body is moving through precisely timed biological states, while the conscious self may later remember almost none of it. It is like an orchestra performing in darkness after the audience has fallen asleep. The music continues. The sections rise and fall. Different instruments take the lead. But the listener who wakes at the end may remember only silence. This silence, though, is not emptiness. It is forgotten structure. And perhaps that is one of the most beautiful truths in the entire topic. Sleep feels like absence in part because so much of its order is not consciously witnessed. The body is still deeply engaged in time. It is just engaged below the level of ordinary awareness. Body temperature offers another gentle clue. Over the course of the day and night, your internal temperature shifts in a circadian pattern. It tends to be higher during the active part of the day and lower at night. That cooling in the evening is part of the transition towards sleep. It is one of the subtle ways the body begins preparing for rest. Then, toward morning, temperature begins rising again as the system starts preparing for waking. This is one reason that when people wake too early in the night, especially if they are anxious or alert, they can feel strangely out of sync, as though they have been pulled into wakefulness at the wrong point in the body's arc. And it is also why the hours just before dawn often have their own unique feeling. The night is still present, but the body is already moving toward another state. Cortisol plays a role here too, though it is often misunderstood. People hear the word and think only of stress, but cortisol is also part of normal circadian physiology. Under healthy conditions, it tends to rise toward the morning, helping support wakefulness and readiness. In a sense, the body begins preparing for your waking before you have fully returned. The biological morning begins before the psychological morning. That is a remarkable thought. It means the body clock is not waiting passively for consciousness to switch on. It is preparing the terrain in advance. And perhaps this helps explain something many people have experienced without fully noticing its meaning. Waking just before the alarm. Not every day, of course, but often enough to feel uncanny. As though some silent part of the body knew what time it was, even in sleep. In a sense, it did. Not by reading numbers. Not by counting minutes like an anxious mind in the dark. But by participating in a rhythm that had been set, entrained, and expected. That ability reveals something important. Sleep may reduce or erase conscious timekeeping, but it does not erase biological timekeeping. The organism remains in time, even when the conscious self no longer feels it directly. And that brings us back to the main thread of the whole video. What happens to time when you sleep? By now, we can answer with more nuance. Measured time continues. Biological time continues. What changes most dramatically is felt time, the conscious experience of moving through duration. The circadian rhythm helps us see that sleep is not an escape from time. It is a different way of being organized within time. And that different organization can affect not only whether you sleep, but how sleep feels, how easily it comes, how deeply it restores, and how the night is remembered afterward. It also helps explain why disrupted schedules can make time feel so strange even when we are awake. If your circadian rhythm is chronically misaligned, days can begin to feel flattened, blurred, or slightly unreal. Morning alertness may not arrive when expected. Evening sleepiness may come at the wrong hour. Mental sharpness, hunger, and emotional steadiness can all become more fragile. In such conditions, time itself can start to feel less trustworthy, not because clocks are wrong, but because your body is no longer moving through the day in the way it was built to. There is something very calming, I think, in realizing how much of human experience depends on rhythm. We often think of ourselves as creatures of thought first. But sleep reminds us that we are also creatures of timing, of cycles, of recurring patterns, of light and darkness, of rising and falling states. The mind may tell itself stories about time, but the body lives by rhythms that do not need language. If this calm exploration is helping you relax, you can subscribe or leave a quiet comment later about whether you tend to feel more like a morning person or a night owl. It is such a simple question on the surface, but underneath it lies this whole hidden world of timing, expectation, and biology. There is one more piece worth touching gently before we close this part. Individual difference. Not everyone's circadian rhythm is identical. Some people really do tend toward earlier sleep and wake times. Others naturally shift later. This is partly why the categories of morning lark and night owl are more than just personality types. They reflect real variation in biological timing. Social schedules, however, do not always accommodate that variation kindly. And when social time and body time clash, people can suffer for it. This is especially clear in teenagers and young adults, whose biological timing often shifts later, while school or work may still demand early waking. The result can be chronic sleep deprivation, irritability, and that heavy, almost unreal feeling of being pulled through morning before the body is ready. Once again, the tension between clock time and internal time shapes lived experience. All of this reinforces a gentle but powerful idea. Sleep is not merely something you decide to do. It is something the body must be able to receive. And the body receives it best when the larger rhythms are respected. Darkness matters. Consistency matters. Morning light matters. The timing of stimulation matters. Not because human beings are fragile in some simplistic way, but because we are rhythmic beings living inside a rhythmic world. And when that rhythm is honored, the night often becomes more intelligible to the organism. The body knows what to do. The descent into sleep becomes less like a struggle and more like an arrival. This does not mean perfect sleep is always possible. Life is far messier than biology textbooks. Stress, grief, illness, work, children, travel, noise, worry, and modern light can all disrupt the night. But understanding the body clock can still make the mystery feel less mysterious. It can show us that the night is not random and that sleep is not merely the mind falling into darkness. It is the whole organism moving through a timed pattern that continues whether or not consciousness keeps pace. And that leads us beautifully into the next part. Because now we have seen 3 layers. We have seen physical time, the measurable unfolding of events. We have seen psychological time, the strange and flexible way the mind feels duration. And now we have seen biological time, the body's internal rhythm guiding the larger architecture of night and day. So the obvious question becomes this: does time itself actually change while you sleep? Not your feelings about it, not the body's readiness for night, not the richness or blankness of dream and deep sleep, but time itself. Does the universe treat a sleeping person differently? Or does sleep only change the way time is experienced from the inside? That is where we go next. Because once we have separated clock time, body time, and felt time, we are finally ready for the clearest answer of all. And it may be simpler and stranger than it first appears. Part 8. Does time actually change while you sleep? By now, the question has become much clearer. Not simpler, exactly, but clearer. We have walked through several layers of the mystery. We have looked at time as physics describes it, steady and measurable. We have looked at the human experience of time, which can speed up, slow down, stretch, blur, or vanish. We have watched awareness soften as sleep begins, and we have stepped into the strange contrast between deep sleep, which can feel almost empty, and dreams, which can feel surprisingly long. We have also seen that even while consciousness drifts and rearranges itself, the body remains faithful to deeper rhythms, to its own clock, its own nightly descent, its own return toward morning. And now we arrive at the question that sits quietly beneath all the others. Does time itself actually change while you sleep? Not your awareness of it, not your memory of it, not your dreams, not your biology, not your feeling of having skipped across the night. Time itself. Does the universe treat a sleeping person differently from a waking one? It is a beautiful question, because it feels like it could go either way. Sleep is such a dramatic shift in experience that it is tempting to imagine it must involve a dramatic shift in reality. After all, if 8 hours can vanish from consciousness, if deep sleep can erase the whole interior texture of the night, if dreams can create what feels like long stories inside short intervals, then surely something profound must be happening to time itself. And in a sense, something profound is happening. But it is not what many people first imagine. The calm answer, the clear answer, the one physics gives us at the scale of everyday life, is this: no, time does not actually change just because you are asleep. Not in the simple sense. Not in the way we mean when we say that 8 hours felt like a second. The clock on the wall does not behave differently because you are unconscious. The earth does not rotate more quickly while you dream. The night does not become physically shorter because your mind was not there to witness it. If you go to sleep at midnight and wake at 8 in the morning, then 8 hours have passed in the external world, regardless of whether those hours felt full, fragmented, or almost non-existent from the inside. That is the starting point. And it matters, because it keeps us from confusing two very different things. One is time as the universe measures it through change, motion, and physical process. The other is time as the mind experiences it through awareness, attention, memory, and selfhood. Sleep changes the second one very deeply. It does not, in ordinary circumstances, change the first. That distinction may sound dry at first, but it is actually the key to the whole mystery. Because once you separate real time from experienced time, much of sleep becomes easier to understand. Imagine a simple room at night. A clock is ticking. A glass of water sits by the bed. The air cools a little toward dawn. Outside, the darkness gradually changes. Somewhere far away, traffic fades, then birds begin. The body in the bed shifts through different sleep stages. Breathing changes. Brain activity changes. Hormones rise and fall. Memory consolidation continues. The heart keeps beating. Cells continue repairing and regulating themselves. All of that happens whether the sleeper is aware of it or not. The room does not wait for consciousness. The universe does not pause until you return. And that is one of the most important truths in all of this. Sleep is not a private pocket outside reality. It is a different relationship to reality. The body remains fully embedded in time. What changes is the style of access the mind has to that unfolding process. In waking life, the mind usually remains connected enough to the stream of events that time feels inhabited. You notice light changing, you hear sounds, you think thoughts in sequence, you remember small transitions, you remain anchored to the flow. In sleep, especially deep sleep, that anchoring weakens or disappears. So the passage of time may later feel compressed, broken, or absent. But the compression happens in experience, not in the external world. This is why two truths can stand side by side without contradiction. One truth says, 8 hours passed. The other says, it felt like nothing at all. Both can be true at once, because they refer to different levels of reality. The physical interval is real. The absence of felt duration is also real. The mistake would be to assume that the second changes the first. There is a helpful comparison here. Think of reading a book so absorbing that you look up and realize an hour has gone by. In one sense, the hour really passed. In another sense, it did not feel like an hour. The difference is not in physics. It is in attention. Sleep takes this familiar phenomenon and makes it far more extreme. Instead of being absorbed in a story, you enter states where awareness itself may fragment or vanish. Of course, time then feels strange. But strange feeling is not the same thing as altered physical time. Still, there is a reason people ask this question so often, and it is not because they're careless. It is because sleep reveals something genuinely unsettling. It shows us that the sense of time passing is not built into consciousness as firmly as we assume. It can disappear. That fact is so surprising that it naturally leads to a deeper suspicion. If our experience of time is this fragile, maybe time itself is stranger than we think. And here, the answer becomes more nuanced. Because while sleep does not change time in the ordinary everyday sense, physics does tell us that time is not as simple and universal as common sense once believed. That fuller strangeness belongs mostly to relativity, and we will come to that more directly in the next part. But even here, it helps to say one gentle thing in advance. Time can, under certain physical conditions, behave differently for different observers. Speed and gravity matter. A clock on a fast-moving spacecraft will not agree perfectly with a clock on Earth. A clock deeper in a gravitational field will tick differently from one farther away. That is real. That is one of the great discoveries of modern physics. But it is not what explains the strange feeling of sleep. This matters because relativity is often pulled into conversations where it does not really belong. People hear that time is relative and wonder whether sleep somehow changes their place in time in a similar way. But falling asleep does not change your velocity in any significant relativistic sense. It does not place you in a different gravitational environment. It does not create the kinds of physical conditions under which measurable time dilation becomes important. You may enter a radically different state of consciousness, but you remain in the same bed, on the same Earth, in the same gravitational field, moving with the same planet through the same night. So the answer remains calm and firm. Sleep does not make time physically speed up. Sleep does not make time physically slow down. Sleep changes your access to the passage of time, not the passage itself. There is something reassuring in that, I think. The universe remains steady even when we do not. The night continues in good order even when the self temporarily withdraws from ordinary awareness. The body is held by rhythms larger than thought. The world is still there, carrying on faithfully, while we move through states that make it feel otherwise. At the same time, there is something humbling in it too, because it means the very powerful feeling that time vanished in sleep is, in one important sense, a construction. Not a fake experience, not an illusion in the dismissive sense, but a product of how the mind processes or fails to process intervals when awareness changes. Sleep teaches us that we do not passively witness time. We actively participate in building the experience of it. That is perhaps the deepest lesson here. Not that time changes while you sleep, but that your sense of time is always more dependent on consciousness than you usually realize. In waking life, this dependence is often hidden. The system works smoothly enough that the world and the mind seem to move together. But sleep loosens the system so completely that the hidden dependence becomes visible. Once awareness fades, the familiar flow of time fades with it. Yet the world outside continues in full fidelity. This split is what makes sleep so philosophically rich. It reveals the difference between reality unfolding and reality being consciously lived. There is another way to approach this, one that may feel more intuitive. Think about a camera set up to record a room overnight. It runs from midnight until morning. It records the changing darkness, the shifting body, the slight motions, the gradual arrival of early light. From the camera's point of view, the entire interval exists as a continuous record. Nothing vanished. The night is there in full. Now think about the sleeper in that room. From the sleeper's point of view, the interval may feel almost non-existent. There may be a few fragments, perhaps a dream, perhaps a moment of turning over, perhaps nothing at all. Morning arrives and the gap remains mostly blank. So what changed? Not the night, not the room, not the passage of time. What changed was the presence of a witness capable of building continuity from within the event. This is why sleep feels so different from, say, simply closing your eyes for a while. In quiet waking rest, you still remain the witness. In deep sleep, the witness becomes faint or absent. And without that witness, lived duration is no longer assembled in the usual way. That is enough to make it feel as though time itself has changed, even when it has not. There is something else worth saying here, because it helps us avoid another common confusion. When we say time does not actually change during sleep, we do not mean sleep is trivial or superficial. On the contrary, sleep is a profound alteration of brain state, bodily function, and conscious experience. It changes how memory works, how attention works, how sensory information is handled, how the self is configured, how emotions are processed, and how restorative biological processes unfold. These are not small changes. They are enormous. But enormous psychological and biological changes do not automatically imply enormous changes in external physical time. This is true in other parts of life too. Grief can make a week feel endless. Joy can make a day disappear. Pain can stretch minutes. Flow can collapse hours. None of this means clocks are wrong. It means consciousness does not experience duration in a uniform way. Sleep belongs to that same family of human truths, though in a much deeper form. And perhaps this is why sleep has always invited both science and poetry. Science tells us the night continues in orderly physical time. Poetry tells us the sleeper falls out of the world and returns by morning. Both are touching something true. Science describes the external continuity. Poetry describes the inner discontinuity. Together they give a fuller picture than either one alone. There is also a practical side to this distinction. When people sleep badly, they often become very aware of time. They check the clock, notice every hour, measure the night against the coming day, and feel trapped inside duration. When they sleep deeply, the opposite happens. The night seems to vanish. Both experiences can tempt us into the same mistake, to think the night itself became longer or shorter. But the night was the night. What changed was how much consciousness held onto it. That can be strangely comforting. It means that a lost night of poor sleep did not literally become longer in the universe. It only became heavier in experience. And a night that vanished in deep sleep did not literally disappear. It only failed to leave the kinds of traces that create lived length. This way of thinking can soften some of the drama around sleep. Not all of it, of course. Fatigue is real, insomnia is real, the body's need for sleep is real. But understanding the difference between real time and felt time helps clarify what is happening. It prevents us from imagining that the whole world has changed when what has changed, mostly, is the form of consciousness. And yet, for all this clarity, there remains a lingering unease. Because even if sleep does not change time itself, it still raises a more unsettling question. Why is our access to time so dependent on consciousness in the first place? Why should the disappearance of awareness make hours collapse into almost nothing? Why should the observer matter so much to lived reality? These are not really questions about sleep alone anymore. They are questions about the nature of mind. Sleep brings them into focus because sleep is where the usual assumptions begin to fail. You stop taking the present moment for granted. You stop assuming continuity is automatic. You stop assuming that time will always feel like a flowing river. Sleep shows that when the mind withdraws, the river may still flow physically, but the sense of standing in it can disappear. This has consequences beyond the night. It suggests that much of waking life is also structured by consciousness more than we normally admit. The way time feels in ordinary experience, too fast, too slow, too empty, too full, may owe far more to the mind's mode of engagement than to the clock itself. Sleep is just the most dramatic proof. If this kind of slow unfolding is helping you relax into the night, you can gently leave a like, subscribe, or later share in the comments whether you've ever had one of those nights where sleep seemed to erase time almost completely. It is one of those universal experiences that still feels quietly astonishing every time it happens. Now let us gather the thread carefully. Does time actually change while you sleep? In the ordinary physical sense, no. The measurable passage of time continues. Clocks continue. The body continues. The universe continues. What changes is not time itself, but your relation to it. Sleep alters attention, memory, selfhood, awareness, sensory engagement, and the continuity of experience. Because of that, the interval may later feel compressed, blank, or distorted. But those are changes in consciousness, not changes in the external flow of events. That is the clear answer. And yet, we are now close to a deeper and more interesting question. Because even if sleep does not physically alter time in the everyday sense, modern physics still teaches that time is not absolute in the old, comfortable way people once imagined. It bends under certain conditions. It depends on motion and gravity. Different observers need not agree perfectly. The universe's treatment of time is more subtle than common sense suggests. So perhaps the final layer of this mystery is not about sleep after all. Perhaps it is about what sleep makes us ready to understand. Because once you have seen how fragile felt time is, once you have seen that consciousness can erase or distort the night without changing the world outside, you are in a better position to appreciate a stranger truth still. The truth that even physics, when followed far enough, does not leave time untouched. And that is where we go next. Into relativity. Into Einstein. Into the difference between the everyday strangeness of sleep and the deeper strangeness of the universe itself. Because sleep does not make time bend, but it may help us understand why the idea of bending time no longer feels impossible. Part 9, Einstein, Relativity, and why this is a different kind of time question. Up to this point, we have been moving through a very human mystery. We began with the strange disappearance of the night. We noticed that when you sleep, especially in deep sleep, time can seem to vanish almost completely. We followed that feeling into the brain, into attention, memory, dreams, circadian rhythm, and the changing structure of consciousness. And along the way, one idea kept returning in different forms. Time, as you live it, is not the same thing as time as a clock measures it. That distinction has carried us through almost the whole journey. But now we come to a place where many people naturally start to wonder about something even bigger. If sleep can make time feel so strange, what about the strange things physics says about time too? What about Einstein? What about relativity? What about the idea that time can actually slow down, stretch, and behave differently depending on motion or gravity? At first glance, it seems as though this should fit perfectly into our story. After all, we have been talking for quite a while now about the weirdness of time, so it is tempting to imagine that sleep is somehow a doorway into the same mystery Einstein uncovered. That maybe when 8 hours feel like nothing, or when dreams seem to contain long narratives inside short intervals, we are brushing up against the same deep physical truth that modern physics discovered in the early 20th century. That is a very understandable thought. But it is not quite right. And this is where the story gets beautifully precise. The strange time of sleep and the strange time of relativity are both real, but they belong to different layers of reality. They are not the same phenomenon. They do not arise for the same reasons. And understanding the difference between them helps make both mysteries clearer. So let us move gently now, because this part can sound technical if handled too quickly. But it does not need to be. At its heart, this is a story about two different questions that just happen to use the same word. One question is this: why does time feel different when I sleep? The other is this: can time itself physically pass at different rates under different conditions? The first question belongs mostly to psychology, neuroscience, and conscious experience. The second belongs to physics. And although they both concern time, they point in very different directions. For most of human history, people imagined time the way it feels in ordinary life. A steady river. One shared flow. Something universal and reliable, moving the same way for everyone. If it is noon for me, then surely it is, in some deep sense, noon for the whole world. If 1 hour passes here, then 1 hour passes everywhere. That picture feels obvious because it fits daily life so well. And for a long time, it also fits science well enough. In classical physics, especially the kind associated with Isaac Newton, time was treated as absolute, a background stage clock for the universe. It ticked the same for all observers, no matter where they were or how they were moving. Events happened within time, but time itself remained fixed and universal. That is a very comfortable idea. It matches instinct. It matches ordinary experience. And at the scale of everyday life, it works remarkably well. If you are baking bread, walking to the store, or trying to arrive at work on time, Newton's kind of time is more than sufficient. The world behaves as though time is shared and steady. For almost everything in normal life, it is safe to think that way. But when physicists began studying light, motion, and the structure of the universe more deeply, cracks began to appear in that picture. And the person who brought those cracks into full view was Albert Einstein. Einstein's great insight, the one that changed our understanding of time forever, did not begin with sleep or consciousness at all. It began with physics asking a very different kind of question. What happens if the speed of light is always the same for all observers? That may sound abstract at first, but the consequences are astonishing. In ordinary life, speeds seem to add together in a simple way. If you are walking forward on a train, and the train itself is moving forward, someone standing outside will combine those motions. Your speed relative to the ground becomes the speed of the train plus the speed of your walking. Simple enough. But light does not behave that way. According to Einstein's theory of special relativity, the speed of light in a vacuum is the same for all observers, no matter how they are moving. This is one of the strangest and most beautiful facts in physics. It means that if two people are moving differently relative to each other, they do not simply add or subtract light speed in the ordinary way. And if the speed of light stays fixed, then something else has to give. That something else turns out to be space and time themselves. This is where relativity begins to reshape reality. To preserve the constant speed of light for all observers, measurements of time and space must become relative to the observer's motion. In other words, different observers moving differently can disagree, not just about where something is, but about when something happens. This is already much stranger than anything sleep does. Sleep changes experience. Relativity changes measurement. Sleep changes the way the mind inhabits time. Relativity changes the structure of time in physics itself. A famous thought experiment helps make this clearer. Imagine a long train moving very quickly along a track. Now imagine two lightning bolts strike the train, one at the front and one at the back. A person standing on the platform, exactly in the middle, sees the light from both strikes arrive at the same moment. That observer concludes the strikes happened simultaneously. But now imagine someone sitting in the middle of the moving train. Because the train is moving, this person is traveling toward the light coming from one strike and away from the light coming from the other. The light reaches them at different times. So from their point of view, the strikes were not simultaneous. Who is right? According to relativity, both are. And that is the beginning of the real shock. There is no single universal, now, shared by all observers in the old absolute sense. Events that are simultaneous for one observer may not be simultaneous for another. Time is not the same simple background river for everyone after all. That is already a deep enough strangeness to sit with for a while, because it means that time in the universe is woven together with motion. It depends, in part, on how you are moving relative to what you are observing. And from there comes one of the most famous consequences of relativity, time dilation. Time dilation means that under certain conditions, time really can pass at different rates for different observers. This is not metaphor. It is not about mood. It is not about how long something feels. It is a measurable physical effect. If one clock is moving very fast relative to another, the moving clock will tick more slowly relative to the stationary one. Not because it is broken, but because time itself is behaving differently along that path through space-time. This has been tested again and again. It is not speculative. It is built into modern physics and even matters for technologies we use every day. GPS satellites, for example, must account for relativistic effects or their timing would drift and their position calculations would become inaccurate. So yes, physics does say that time can behave differently. But here is the gentle correction that matters for our sleep question. You do not experience the night as brief because you underwent significant relativistic time dilation in bed. That is not what is happening. When you fall asleep, your body is not suddenly traveling near the speed of light. You are not plunging into an extreme gravitational environment. You are not entering the sort of physical condition that would make relativity relevant in that way. The effects of relativity do exist in the real world, but at the scale of normal sleep on Earth, they are far too small to explain why the night can feel like a blink. That feeling comes from a different source entirely. It comes from consciousness. It comes from the weakening of the observer. It comes from changes in memory, awareness, and the brain's ability to build a lived sequence of moments. This distinction is worth repeating because it is the heart of Part 9. Relativity tells us that time itself can differ between observers under certain physical conditions. Sleep tells us that the experience of time can differ dramatically depending on brain state and consciousness. Those are two different kinds of different. One is physical. The other is psychological. One changes measured time. The other changes lived time. And the beauty of understanding both is that you no longer need to confuse them in order to appreciate how strange each one truly is. There is another layer to this difference, and it may be the most calming one. Relativity is not about being bored, dreaming, resting, forgetting, or losing track of duration. It is not about the softness of experience. It is about the geometry of spacetime itself. It tells us that time is bound up with space in a deeper structure, and that motion and gravity influence how intervals are measured. Sleep, by contrast, happens inside that structure. Your body remains embedded in ordinary spacetime. The room remains in ordinary spacetime. The clock remains in ordinary spacetime. What changes is not your place in the geometry of the universe, but the way your mind is participating in the unfolding of that geometry. There is something very grounding about that. It means that your strange sense of skipping across the night does not require the universe to become exotic each evening. The universe remains steady enough. The exotic thing is the mind. Or perhaps more gently, the flexible thing is the mind. And yet, even after we make this distinction, Einstein still matters here. Not because relativity explains sleep directly, but because sleep prepares us to understand a world in which time is less simple than common sense suggests. Before thinking deeply about sleep, many people assume time must always feel like a smooth, continuous flow. Sleep quietly breaks that assumption. It shows that the present can go missing, that duration can collapse, that the witness matters. Once you have truly felt that, relativity seems less impossible. You begin to see that the time of daily instinct may not be the whole picture. Sleep humbles our intuitions from the inside. Einstein humbled them from the outside. That is a lovely symmetry. One does it through consciousness. The other does it through physics. And together they teach the same broader lesson. Time is not as simple as it first appears. There is another way to say it. Sleep teaches that the flow of time, as felt, depends on the mind. Relativity teaches that the measurement of time, as physics describes it, depends on the frame of reference. Those are not identical truths, but they rhyme. And perhaps that is why they are so often confused. They both weaken the old fantasy of one simple, unquestioned time. They both tell us that time is relational in ways our ancestors did not fully imagine. Still, it is important not to overstate the connection. A dream that feels like a long journey is not a relativistic event. A night of deep, dreamless sleep that vanishes from memory is not the same as a clock slowing due to velocity. If we mix these together carelessly, we lose the particular beauty of each. So let us keep them distinct. When you sleep, the reason time feels strange is that consciousness changes. When a fast-moving clock runs differently from a slower one, the reason time changes is that spacetime itself behaves according to relativity. Two mysteries, two levels, one word. That brings us to another important question. If relativity does not explain why sleep feels short, then why bring Einstein into this at all? Because relativity helps protect us from a common misconception. The misconception is that since time feels strange in human experience, physics must be saying exactly the same sort of thing. But physics is saying something subtler and, in its own way, even stranger. It is not saying, time is whatever you feel. It is saying, time is woven into the physical structure of the universe more flexibly than classical common sense allowed. That is a very different claim. Your feelings do not alter relativity. Your awareness does not cause time dilation. Your dreams do not bend spacetime. And yet, The fact that time can be strange both in experience and in physics makes the subject endlessly fascinating. It is almost as though time sits at the crossroads of two worlds: the outer world of measurement, structure, motion, and gravity, and the inner world of memory, attention, selfhood, and consciousness. We spend most of our lives moving between those worlds without clearly noticing the difference. We say things like, "That day flew by," and "Time slowed down," and "Where did the night go?" And at the same time we trust our clocks, our calendars, our astronomical predictions, and our physical equations. Usually the two worlds cooperate well enough that no confusion arises. Sleep is one of the rare places where the inner world and the outer world pull far enough apart that we are forced to notice. You wake and realize that the clock insists on one story while your mind insists on another. The clock says, 8 hours passed. The mind says, it felt like almost nothing. And from there, if curiosity is awake enough, a deeper question emerges. If my own experience of time is this flexible, then what exactly is time beneath that experience? That is the question relativity belongs to. Not the question of how the night feels, but the question of what kind of universe could contain such feelings at all. There is a calm beauty in letting both truths coexist. The first truth is intimate. Sleep does not bend physical time, but it changes your access to it so completely that hours may vanish from experience. The second truth is cosmic. The universe itself is not governed by one absolute, shared time in the old Newtonian sense. Time is bound up with motion, gravity, and spacetime. One truth belongs to the bedroom. The other belongs to the stars. And perhaps the reason they feel related is that both ask us to loosen our grip on the most naive version of reality. The idea that time is just a simple river flowing the same way for all things at all times. Sleep complicates that idea personally. Einstein complicates it physically. This is why Part 9 matters. It prevents us from making the easy mistake of collapsing all strangeness into one pile. Not all strange experiences of time are the same. Dream time is not relativistic time. Missing time in deep sleep is not time dilation. Boredom, flow, jet lag, REM sleep, and special relativity all involve time, but in different ways. That does not make the topic less magical. It makes it richer. Because now you can see that there are multiple kinds of mystery here. There is the mystery of the brain constructing a present. There is the mystery of the body keeping circadian order. There is the mystery of the self disappearing into dreamless sleep. And there is the mystery of the universe itself, where clocks moving differently through spacetime need not agree. Each mystery keeps its own dignity. Each deepens the others without becoming them. If this slower kind of thinking is helping you unwind, you can gently subscribe, leave a like, or later tell me in the comments whether the strangeness of time feels more unsettling or more comforting to you. For some people, these ideas make the universe feel cold. For others, they make it feel more beautiful. Perhaps both reactions are understandable. Now let us draw the thread together. Einstein and relativity belong in this conversation not because they explain why sleep feels short, but because they clarify what sort of question that really is. Sleep is not a case of physical time bending in the relativistic sense. It is a case of consciousness changing so deeply that the lived sense of duration becomes fragmented, compressed, or absent. Relativity is a different kind of time question. It asks how time behaves in the physical fabric of the universe. Sleep asks how time behaves in experience when awareness changes. And now that we have separated those clearly, we are ready for the final movement of the whole script. Because once you see the difference between physical time and felt time, and once you understand that sleep mostly changes the second rather than the first, a quieter and more philosophical question begins to emerge. What does it mean that so much of life's passage depends on how it is experienced? What does it mean that whole nights can disappear from memory, while brief dreams can feel expansive? What does it mean that the universe keeps moving faithfully forward, even when the self temporarily falls away? And perhaps most gently of all, why does sleep make time feel as if it vanishes, and what does that reveal about being a conscious creature at all? That is where we go next. Into the final reflection. Not on Einstein alone, not on dreams alone, but on the larger truth they both help illuminate. That time may continue without asking anything of us. But the feeling of living through time, that fragile, intimate thing, depends on a mind that is only here part of the time. Part 10. Why sleep makes time feel like it vanishes? There is a quiet strangeness waiting for all of us tonight. You will close your eyes, as people have done for thousands of years, and at some point the day will simply stop belonging to you. The room will still be there. The air will still move. The earth will still turn under the stars. Somewhere, clocks will continue their patient work, counting each second with perfect indifference. But for you, for the version of you that usually lives moment by moment inside experience, something remarkable will happen. The night will loosen its grip on your awareness. And if sleep is deep enough, gentle enough, complete enough, it may feel in the morning as though a whole portion of existence was never really there at all. That is the mystery we have been circling from the beginning. Why does sleep make time feel like it vanishes? Not in poetry alone, though poetry has always understood this. Not as metaphor alone, though metaphor reaches for it beautifully. But in the real, intimate, human sense. Why can 8 hours leave so little behind? Why can a night be physically long and experientially weightless? Why does a sleeping mind sometimes erase time, sometimes stretch it into dreams, and sometimes return to morning with nothing but a clean, unbroken gap? By now, we know the answer is not one single thing. It is not simply physics. It is not simply psychology. It is not simply the brain, or the body, or the clock on the wall. It is the meeting point of all of them. And when we gather everything together, the picture that emerges is not only scientific, it is deeply human. Because sleep does not really make time vanish from the universe. It makes time vanish from the story the mind is able to tell about the universe. That is the heart of it. All through this journey, we have kept returning to the same gentle distinction. There is measured time, the kind that belongs to clocks, astronomy, motion, and physical process. And there is felt time, the kind that belongs to attention, memory, awareness, emotion, and selfhood. Those two often move together closely enough that in ordinary life we barely separate them. But sleep pries them apart. And once they are pried apart, the illusion of a single, unquestioned time begins to dissolve. When you are awake, your mind is usually busy building continuity. It stitches together one moment with the next. It keeps track of the room, the body, your thoughts, your plans, your small transitions from one state to another. Even when you are distracted, even when you are tired, even when the day blurs a little, there is still enough conscious structure for time to feel inhabited. It may feel fast or slow, pleasant or oppressive, but it still feels like something. Sleep changes that. As awareness fades, the mind begins letting go of the very functions that normally make duration feel real. Attention relaxes. Sensory anchoring weakens. Self-monitoring softens. Memory formation changes. The waking narrative breaks. In deep sleep, the observer who usually stands inside the stream of time almost disappears. The body remains in the night. The world remains in the night. But the witness, the familiar one who would normally say, "I was here while this passed," is no longer present in the same way. And if the witness is absent, then duration loses its ordinary form. That is why deep sleep feels so close to timelessness. Not because time stopped, but because the part of you that usually converts passing time into lived experience went quiet enough that almost no subjective trail remained. This is one of the most astonishing things about being human. We do not merely exist in time the way stones exist in time. We experience time. Or perhaps more carefully, we construct an experience of time. We take sequence, change, and continuity, and we make from them a lived present. We do this so effortlessly while awake that it feels natural, inevitable, unquestionable. Then sleep comes each night and shows us how conditional that construction really is. It is hard to overstate how profound that is, because it means one of the most basic features of daily life, the feeling that you are moving steadily through time, is not simply handed to you raw by the universe. It depends on a certain kind of consciousness being active, a consciousness that is attentive enough, reflective enough, anchored enough, and memory-forming enough to build duration from within. When that kind of consciousness fades, time, as felt, begins to fade with it. And yet, the body never leaves time behind. This is the second great truth of sleep. While your conscious experience becomes strange, compressed, or absent, your biology remains beautifully ordered. The circadian rhythm continues its work. Hormones shift according to the larger cycle of the night. Body temperature falls and rises in its ancient arc. Sleep pressure eases. Different sleep stages unfold in patterned sequences. Deep sleep becomes more prominent earlier in the night. REM expands later. Morning begins forming chemically before you feel it consciously. All of this means that the night is not chaos. The night is structure without witness. The body knows what to do even when the conscious self no longer narrates the process. That alone is a deeply comforting thought. There is an intelligence in life below deliberate awareness. There is a timing older than your plans and more faithful than your moods. Even while your experience of the night becomes broken, blank, or dreamlike, the organism remains held inside a larger rhythm. This is why sleep is not just the absence of waking. It is another mode of order. The mind may feel as though it vanished from time. The body did not. And then there are dreams, which complicate the mystery in the most beautiful way. Because if deep sleep erases time, dreams seem to bring it back, though not in its ordinary shape. In dreams, the mind becomes a storyteller again. It generates scenes, worlds, people, motion, danger, longing, recognition, loss, reunion. It does not restore the clean, measured continuity of waking life. Instead, it invents an inward time, elastic and symbolic. A brief REM period can feel like a long journey. A small fragment of the night can contain the emotional architecture of something much larger. Dreams show us that the mind is not only capable of losing time, it is capable of remaking it. That matters, because it reveals that felt time is not a single function with one setting. The mind can erase duration under some conditions and expand it under others. It can move from blankness to narrative, from near nothing to a whole world, all within the same biological night. That is not something a mechanical clock can do, but consciousness can. And in that sense, sleep may be the most powerful everyday demonstration that the human experience of time is a creation, fragile, flexible, and deeply dependent on brain state. Now, when people hear all this, it is natural for them to drift toward a bigger and more unsettling question. If sleep can make time vanish from experience, and if dreams can make a few minutes feel long, then what exactly is time beneath all this? Is it just a trick? Is it all subjective? Is the universe itself unstable in the way our experience is unstable? That is why we brought in Einstein. Not because relativity explains why sleep feels short. It does not. Sleep is not a relativistic event. You are not bending space-time by lying in bed. You are not entering the kind of physical condition that makes clocks diverge in the way relativity predicts. The strange time of sleep belongs mostly to consciousness, not to motion and gravity. But Einstein still mattered for one important reason. He showed that even at the level of physics, time is not as simple as instinct suggests. There is no single absolute, universal, now, shared in the old Newtonian way. Under certain physical conditions, time itself can be measured differently by different observers. That is a different mystery from sleep, but it rhymes with it. Sleep loosens our trust in felt time from the inside. Relativity loosens our trust in simple physical time from the outside. Together, they teach humility. They teach that time is not the easy, unquestioned thing we once imagined. But the final lesson of sleep is still gentler than that. Sleep tells us that what vanishes each night is not time itself, but our claim on continuous experience. That may be the most human phrasing of the answer. When you sleep, especially in deep sleep, you temporarily surrender the ongoing authorship of your own moment-by-moment life. You are still alive. You are still in the world. Your body is still engaged in the night. But the self that usually tracks, counts, worries, anticipates, and remembers steps aside. And because it steps aside, the night often leaves far less psychological weight than its physical length would suggest. This is why waking from deep sleep can feel almost magical. Not because anything supernatural has happened, but because the ordinary assumptions of consciousness have been suspended so completely that their return feels like re-entry. Morning arrives not as the end of a long-witnessed interval, but as a kind of reappearance. You were here. Then you were gone from yourself. Then you were here again. That sounds dramatic when said that way, but it is the simplest thing in the world. It is sleep. It happens every night. And because it happens every night, we forget how extraordinary it is. Perhaps that is one reason sleep has always carried a philosophical shadow around it. It resembles death just enough to unsettle us, and renewal just enough to comfort us. It shows us a state in which the world goes on without our awareness, and then it gives us back to ourselves by morning. It reminds us, quietly, that we are not the custodians of reality. The world does not need our consciousness in order to continue. Yet at the same time, it reminds us how much of what we call life depends on that consciousness. Because when consciousness withdraws, time as lived withdraws with it. There is a tenderness in that realization. It means that your days do not merely happen to you. They are lit from within by awareness. A waking hour feels like something because someone is there to gather it. Your joys feel full because they are attended to. Your pain feels long because it is inhabited. Your memories feel extended because they were lived through with enough continuity to become part of the self-story. Sleep strips that process back and shows its foundations. It says, in effect, look how much of your reality depends on a mind being present to it. That can sound unsettling at first, but I think there is comfort in it too. Because if the felt passage of life depends so much on attention, memory, and conscious presence, then it also means the quality of life is not only measured by the clock. It is shaped by how fully it is inhabited. A distracted week can vanish. A meaningful evening can remain spacious in memory. A deep sleep can erase hours. A vivid dream can make minutes feel rich. Time, as lived, is not simply what passes. It is also what is noticed, what is felt, what is remembered, what is given form inside experience. Sleep reveals this not by argument, but by demonstration. Every night, it performs the experiment again. Every night, it asks, what becomes of duration when the witness fades? And every morning, in one form or another, it gives us the answer. Sometimes the answer is a blank. Sometimes it is a dream. Sometimes it is the peaceful shock of seeing light through the curtains and realizing how little of the night survived as experience. That last feeling may be the purest expression of the whole mystery. You know the night existed. You know it had length, but you did not carry that length within you. And so it feels, not unreal, but strangely absent. This is why the phrasing matters so much. Sleep does not destroy time. It removes your ordinary participation in its passage. And once you see that, the question becomes broader, almost philosophical in the calmest possible way. What else in life feels longer or shorter not because the world changed, but because awareness changed? How much of our suffering comes from heavily inhabited time? How much of our joy comes from richly attended time? How much of our life disappears because we are present to it only weakly, while other brief moments expand because we were fully there? Sleep is a nightly reminder that lived reality is always more than external measurement. And perhaps that is why it matters so much for a human being trying to make sense of existence. We are not clocks with skin. We are conscious creatures. We live not only by duration but by depth, not only by sequence but by presence. The body moves through time biologically. The world moves through time physically. But the self moves through time experientially. Those three movements overlap, and yet they are never quite the same. That is the whole story in miniature. Physical time continues whether or not you notice. Biological time organizes your night whether or not you understand it. Experienced time appears and disappears according to the changing structure of consciousness. And sleep is where those three layers become impossible to confuse. There is something calming in reaching the end of the question this way. We do not need to imagine sleep as a supernatural time tunnel. We do not need to make the universe exotic in order to explain what is already strange enough. The truth is subtler, and perhaps more beautiful. The night feels like it vanishes because the mind that would normally turn it into a lived sequence is no longer fully present to do so. The world remains faithful. The body remains rhythmic. Consciousness loosens, and the story of time temporarily falls silent. Then morning begins, and the story resumes. If this slow journey through the science of sleep and time has helped you relax, you can quietly leave a like, subscribe, or share in the comments what your own nights feel like. Do they disappear? Do your dreams feel long? Do you ever wake with that strange sense that the dark hours had almost no inner shape at all? Those little reports from real people are often the most beautiful part of these conversations, because they remind us how universal and how personal this mystery really is. And now, before we leave the question entirely, let us rest in one final thought. Tonight, when sleep comes, you do not need to force yourself to understand every second of it. You do not need to stand guard over the dark. You do not need to witness the whole night for it to carry you where it is meant to carry you. Your body knows rhythms your thinking mind does not. Your brain knows how to loosen the self, how to descend, how to repair, how to cycle, how to return. And when morning comes, even if the night feels as though it vanished, something real will have happened. Not just the passing of hours, but the temporary surrender of the waking self. The quiet proof that time can continue without being felt. The gentle reminder that consciousness is precious precisely because it is not constant. And maybe that is the deepest answer of all. Sleep makes time feel like it vanishes because time, as you live it, is not only out there in the world, it is also in here. In attention, in memory, in awareness, in the self who says, I was here. When that self grows quiet, time does not end, but its voice does. And for a few dark hours, the universe keeps moving without asking anything more from you than this. To let go, to drift, to disappear from the story for a while, and then, with the morning light, to return.